हाँ जी. Good morning. We are here now for complex numbers part 2. We have already done complex number part 1 that we discussed last time. Now, for complex number part 1, what you do is you recall this thing that what I told you, that in the complex plane, if you have 2 points, say Z1 is here, Z2 is here, then what is distance AB equal to? Mod of Z2 minus, that is mod of Z2 minus Z. Is it okay? Now, can we have the first question from PPT? No, question. Second PPT. आगे चलिए. और क्वेश्चंस होंगे उस पे. मेरे ख्याल से पेज नंबर थोड़ा सा और आगे. Next. Yes, please come to question 1. All right, we are looking, this is a question from your paper. The number of complex numbers Z such that mod of Z minus 1 is equal to mod of Z plus 1, that is equal to mod of Z minus I. Can you tell me how many complex numbers are there which satisfy this property? How will you do it? Yes, anybody? All right, let's look at what we are trying to get. We are trying to get all those complex numbers which satisfy this condition, isn't it? See, you are interested in all those complex numbers which are equidistant from what points? Mod of Z minus 1, that means if you take some point Z, what is this? This is 1. You're interested in all those points, isn't it? And second, mod of Z plus 1, what is that? Is that the distance between Z and minus 1? Isn't it? That is the distance between Z and minus 1. Is it okay? And what is the third point? Third point is the distance between Z and I. Where is I? I is here. That means we are interested in all those points which are equidistant from 1, minus 1 and I. Tell me how many complex numbers are there? You have the options before you. Okay, let me ask you. See, don't you think that Z should be center of the circle passing through 1, minus 1 and I? Isn't it? In other words, Z is center of the circle passing through 1, 0, minus 1, 0 and 0, 1. How many centers are there? Exactly 1. So there is only one point which satisfies all this. Isn't it? There is exactly one point which satisfies all the three conditions. And what is that point? No. Yes, sir. What is that center? Origin. Because 0 is that point which, if you put Z is equal to 0, you will be getting that Z 0 minus 1, that is equal to 1. 0 plus 1, modulus of that will be equal to 1. And 0 minus I, modulus of that will be also equal to 1. Isn't it? See, please see once again. There exists one and only one circle that passes through three non-collinear points. Here you had three non-collinear points, minus 1, 1 and I. Isn't it? You have three non-collinear points. There is exactly one circle which passes through these points and there will be exactly one center. Is it okay? So you have number of points is exactly 1. Is it okay? Now let me change it slightly. Let's change the question slightly. Now let's say that we are interested in all those points. We're interested in all those points which are like this. Yes, we're interested in all those points which satisfy these conditions. Your options are once again continue to be the same. 2, infinity, 0 or 1. Yes. Yes. What did you say? That is, you said number of points is 0, or you are saying z is equal to 0? Number of points is 0. Certainly 0. Because what did you get? You got that this condition is being satisfied by only one point, namely 0. But that's not being satisfied by the last condition, isn't it? So you have number of such points is going to be 0. That you can see immediately. What you have is, from using the first 3, you will be getting this circle. All right, that passes through I, 1, minus 1, and minus 1, minus I rather. Isn't it? Is it okay? And where is 2I? 2I is here. So there is no such point, isn't it? Because the distance, there is only z is equal to 0 satisfies the first 3 condition, but that's not being satisfied by the fourth thing. Is it okay? So there is number of complex numbers is going to be 0. Is it clear? All right. Had it been z plus I, our answer would have been 1, because then the points would be concyclic. Is it okay? Can we have next question, please? All right. You have, if alpha beta are distinct complex numbers with mod of beta is equal to 1, then what is the value of mod of beta minus alpha over 1 minus alpha bar beta? This also is a question from your paper, previous year's papers. Now, can any one of you tell me how to do this? Yeah, what is your line of thinking? By? By replacing alpha by conjugate of? That means you're saying that we must replace this alpha bar by 1 by alpha. But how can you do that? No, and what, see, you can do it only when you're given that mod of alpha is 1. We are given only mod of beta is 1, not mod of alpha. You got the point? That is, see, you are trying to use that mod of alpha is equal to 1, which is not given to us. We are given that mod of beta is equal to 1. Okay, so we cannot use that. All right, what other thing which you can think of? Okay, you see, SC suggested that we replace alpha bar by 1 by alpha. But let's try to replace this beta by 1 by beta bar. Okay, let's try to replace this beta by 1 by beta bar, because you have this, you got beta, mod of beta is equal to 1. That implies mod of beta square is equal to 1, which implies beta into beta bar, that is equal to 1. So beta bar is equal to what? 1 by beta. Is it all right? Now let's come to this. What is this equal to? Beta minus alpha over 1 minus alpha bar beta. All right. I will replace beta by 1 by beta bar. Okay, I will replace beta by 1 by beta bar. If I do that, what I'll be getting? I'll be getting here beta minus alpha. I'll replace only this thing. 1 minus alpha bar by beta bar. Is it all right? Will you be getting this? Now, what about this equal to? Is it equal to beta bar? Please check and tell me. Is it equal to this? You're simply simplifying it, bringing beta bar here and bringing this beta bar in the numerator. Okay. What about this mod of beta bar? This is 1, isn't it? If mod of beta is 1, mod of beta bar is also 1. What about the second one? What is that equal to? That's also 1, because you have that, you got in the numerator you got beta minus alpha, whereas in the denominator you got beta bar minus alpha bar. And please remember that modulus of complex number and its conjugate, they are equal, isn't it? Modulus of the complex number and its conjugate are equal. That means we can replace this by 1. This is also 1. So what will be your answer? Your answer will be equal to 1. Okay. You have, if alpha beta are distinct complex number with mod of beta is equal to 1, then you have this expression, modulus of that expression should be equal to 1. Okay. Can we go to the next question, please? All right. This is question number 3 for you. Before we go to this question, all right, let's please wait for a few minutes. We'll return to this in a minute. See, if you have that A belongs to the set of complex numbers, all right, and R is positive, then what is mod of Z minus A is equal to R? What does it represent? What is this curve? It's a circle. Is it a circle with center at A and radius equal to R? You have all complex numbers which are at a distance A, which are at a distance R from A, isn't it? So mod of Z minus A is equal to R. What does that represent? That represents, you have, this is A, it represents all complex numbers Z such that, okay, so this is going to be a circle. Now, if I make it like this, mod of Z minus A is less than equal to R, then what does it represent? It represents the entire disk. Is it okay? That is, it represents the interior as well as boundary of that circle. Okay, now you can go to this question. All right, let's return to it. What is this? Mod of z plus 4 is less than equal to 3. What does it represent? It represents a disk with center at minus 4, isn't it? It represents a disk with center at minus 4 and radius equal to 3. All right, let's plot that disk. This is minus 4. This distance is 3. What will be this point? What will be this point? What will be this point? Minus 1, isn't it? This is minus 4 and this is 3. This is 3. That means this distance must be minus 1. And what about this? Minus 7. Very good. Now let's see what our question is asking us. Our question is asking us that you have Z to be points either on the boundary or in the interior of this circle. Okay. And what we are looking for? We are looking for that point which gives us the maximum value of mod of Z plus 1. That is, we are looking for that Z which will tell us that the distance from this, it should be maximum. Can you say without calculating what it should be? 6, because the maximum distance which you can get is the diameter, that is equal to 6. Isn't it? Maximum distance which you can get is equal to the diameter, that is equal to 6, and that value will be attained for Z is equal to minus 7 and for no other value. Okay, any doubt? Please don't hesitate. If you have any doubt, do ask it. Shall I explain once again? See, what does mod of Z plus 4 less than equal to 3 represent? It represents a disk with center at minus 4 and radius equal to 3. All right. We have Z can be any point either on this circle or in the interior. Okay. Now, you are looking for that point for which mod of Z plus 1 becomes maximum. Minus 1 is on the circle, isn't it? Z is either in the interior or on the circle. Okay. Then, so what do you get? You can take any point inside or on the boundary of the circle. The maximum value will be attained when Z is the opposite endpoint of the diameter corresponding to minus 1. Okay. That point happens to be minus 7. Okay. What will be the minimum value of mod of Z plus 1? What will be the minimum value of mod of Z plus 1? That will be 0. Isn't it? That will correspond to Z is equal to minus 1. Okay. That will correspond to Z is equal to minus 1. You will be getting the minimum value is 0. Maximum value is 6. Is it okay? Can we go to the next thing? All right. If Z satisfies the relation that mod of Z minus I mod of Z is equal to Z plus I mod of Z, modulus both the sides, then you have to tell whether which of this is true. Imaginary Z is 0, mod of Z is 1, real Z is 0, or none of this. Okay, tell me one thing. Does Z is equal to 0 satisfy this relation? check and then tell. Does it? Because you have 0 minus 0 minus 0 minus I0, that will be 0. And 0 plus I0, that will be also 0. That means Z is equal to 0 certainly satisfies this relation. But that does not help us much in finding out the answer. All right. If we Z is equal to 0, we have already found that satisfies this relation. Okay. Let's take Z not equal to 0 and see for non-zero values of Z, what values we can obtain from this relation. All right. See, you got what? You have Z minus I mod of Z, that is equal to Z plus I mod of Z. All right. Because Z is not equal to 0, I can divide this relation as well as this by mod of Z. Because Z is not equal to 0, we can divide both the sides by mod of Z without any problem. Okay. If you divide by mod of Z, what do you get? Do you get this? Do you get this? Is it okay? What does it tell? What does it tell us about Z by mod of Z? Yes. What does it tell us? What does this relation tell us about Z by mod of Z? It is? Yes. Origin we have already found out, because origin तो नहीं ले सकते ना बेटा. Z not equal to 0. That is, see, it is equidistant from minus, this is equidistant from I and minus I, isn't it? That means Z by mod of Z should be where? On the real axis, isn't it? That is, Z by mod of Z lies on the perpendicular bisector of this segment, isn't it? It lies on the perpendicular bisector of this segment. Perpendicular bisector of this segment is real axis or the x-axis. Is it okay? That means Z by mod of Z is a real number. Okay. If mod of Z is, if Z is not equal to 0, then Z by mod of Z should be real number. If Z by mod of Z is real number, then what is Z? Should also be real number, isn't it? Therefore, Z must lie on the real axis. If Z lies on the real axis, imaginary Z is 0. There we are. Okay, we get imaginary Z is 0. All right, comfortable? Can we go to the next thing? All right, let's go to the next. Okay, this question. The number of solutions of Z square plus mod of Z bar, sorry, Z square plus Z bar is equal to 0. You said 1. Who said 1? How did you reach that? Putting Z is equal to 1, that does not satisfy it. Look at it. 1 square will be 1. 1 bar will be also 1. Isn't it? It will be 2. Not Z is equal to 1. And secondly, we are looking for the number of values of Z. Okay, we are not looking for what are the values of Z. Please see the question. Question is find the number, isn't it? We are interested in number of solutions. That is Z which satisfy this relation. One thing which you can immediately see is 0. Isn't it? All right, 0 is certainly a solution of it. But what are the other solutions? In fact, I am not interested in the other interested in the solutions. I am just interested in number of solutions. No, there are other solutions also. For instance, if you look at it, -1 will also satisfy. -1 will also satisfy this. 2. Now try a little more. थोड़े से और भी हैं. All right, let me tell you how to solve such equations. Okay, let's see. See, you got z square plus z bar is equal to 0. Immediately, what you obtain is this, that z square is equal to minus z bar, isn't it? Take the modulus both the sides. If you take the modulus both the sides, will you be reaching this? Is it okay? And what is minus of z bar? Is it equal to mod of z? All right. What does it give you? That implies that mod of z into mod of z minus 1, that is equal to 0, which implies what? Mod of z is equal to 0. Okay. Mod of z is equal to 0 or mod of z is equal to 1. But what does mod of z is equal to 0 give you? Mod of z is equal to 0 gives you only one value, namely 0. Isn't it? Remember that mod of z is equal to 0. This is equivalent to say that z is 0. Okay. Now mod of z is equal to 1. All right. Mod of z is equal to 1. Mod of z is equal to 1 will give you that z bar that is equal to 1. That will imply z bar is 1 by z. All right. You come back to this equation. What do you get? You get z square is equal to minus 1 by z. Isn't it? What does it give you? Z cube is minus 1. All right. This is z cube is minus 1. How many solutions does it have? 3. So total number of solutions is 4. All right. Total number of solutions is 4. See, please see, we have not been asked to find the solutions. Isn't it? We are interested in the number of solutions. Z cube is equal to minus 1 will give us 3 solutions. Of course, we are not interested in what are those solutions. We are merely interested in finding the number. Number is going to be 3. Okay. Otherwise, how will you get the solution of this? What are the solutions of z cube is equal to minus 1? No, not 1. Minus 1. What else? Yes, minus 1 minus omega square. Is that all right? There will be 3 solutions of this equation. One we have obtained from z, one we have obtained is z is equal to 0. So the total number of solutions will be 4. Okay. So for instance, let me change this equation. Let me make it z is to the power of 2016, the year in which you are going to appear in your examination. All right. How many solutions does it have? Proceed exactly on the similar lines. All right. This will be 2016. Other thing will remain the same. Will you be getting this 2015 here? Okay. This will give you mod of z is equal to 0 and mod of z minus 2015 is equal to 0 will lead you to only this equation. Isn't it? Mod of z to the power of 2015 is equal to 1 will lead you to only one equation, that mod of z is equal to 1. Use that, you will be getting what? Mod of z is equal to 1 will imply z into z bar is 1 by z. This will be 2016 here. You will bring it here, this side. This will become what? 2017. How many solutions it has? 2017. One we have obtained is z is equal to 0. That means the total number of solutions will be 2018. Is that all right? Okay. So that number is not going to be a problem. कि यहाँ पर क्या आ रहा है? That's not going to be a problem. Method will remain the same. All right. Method will remain the same. Can we have the next one? This one. there is a request from the online students who want this questions to be explained again. See, you have z square is equal to minus z bar. All right, z square is equal to minus z bar. Let's take modulus both the sides. If you take modulus both the sides, what do you get? Z square is equal to minus mod of z bar. This implies what? Mod of z whole square is equal to mod of z. Because you recall that I told you that modulus of z, modulus of minus z bar, modulus of minus z, and modulus of z, they are all equal. Is it okay? So you have mod of z square is equal to mod of z. All right. Now, here is one thing let me point out. What the students do is they immediately cancel mod of z. You should not do it, because you can cancel mod of z only under the condition that mod of z is different from 0. From here you will go to this equation. This will imply mod of z is equal to 0, mod of z is equal to 1. Mod of z is equal to 0. What does it give you? Mod of z is equal to 0 will give you z is equal to 0. Okay. Let's use the other condition that mod of z is equal to 1. Mod of z is equal to 1. Mod of z is equal to 1 will imply what? Mod of z square is equal to 1. That implies z into z bar is equal to 1. That will imply z bar is 1 by z. Let's substitute this here. Okay, let's substitute it here. If you substitute it here, you will be getting z square is equal to minus 1 by z. That implies z cube is equal to minus 1. Now, this is an equation which is going to have 3 solutions. Of course, we are not interested in those solutions. We are merely interested in the number. But otherwise, its solutions are minus 1, minus omega square. Okay. And we have already obtained one more solution, namely z is equal to 0. That means the number of solutions is going to be 4. All right. Can we go to the next thing? All right. We have if z minus 4 by z is equal to 2, then the maximum value of mod z is what? Another question. Question 5. How z? Question 5 देखना पड़ेगा कौन सा भी देख लेते. How z equal to 1 by z in question 5. इसको लास्ट में ले लें. ठीक है, लास्ट में ले लेते हैं, फिर दोबारा आना पड़ेगा. All right, because the time constraint, I cannot give you more time to try questions. See, you wish to find out what is the maximum possible value of mod of z, provided z satisfies this condition. Okay. Do you remember this inequality? Okay, this is you can derive from triangle inequality. All right. Now, please see. Can you say, look at it, mod of z minus 4 by mod of z. All right. Look at this, mod of z minus 4 by mod of z. Is it less than equal to mod of z minus 4 by mod of z? Is that less than equal to z minus 4 by z? Please check and tell me. Can you do that? Yes. Can you do that? Remember, see, this you know that comes from here, isn't it? That comes from here. But you also remember one thing, that x is always less than equal to mod of x. X is always less than equal to mod of x for each x belonging to the set of real numbers. Okay, we are using that. You take this as x. All right, you get that mod of z minus 4 mod of z, that is less than equal to this, which is going to be less than equal to that. What is given us to be equal to this? 2. That's given us to be 2. Is it okay? What does this imply? Does it imply this equation? Multiply both the sides by mod of z, you get mod of z square minus 4, that is less than equal to 2 times mod of z. Okay. Does it imply that mod of z minus 1 whole square, that is less than equal to 1 plus 4, that is 5? Check. I bring it this side, you get mod of z square minus 2 mod of z. I add 1, I'll be getting mod of z minus 1 whole square is less than equal to 1 plus 4, that is 5. Is it okay? Please see, what does it give you? You remember what does this give you? X square is less than equal to a square. Does it imply that minus a is less than equal to x is less than equal to a? This is a chapter in your NCERT book, inequalities. All right, x square is less than equal to a square. That means that minus a is less than equal to x is less than equal to a. All right, can you conclude from here? Does it imply 1 minus root of 5? This is less than equal to mod of z is less than equal to root of 5 plus 1. Does it imply this? Okay, you have mod of z is less than equal to root of 5 plus 1. So what is the maximum possible value of mod of z? Root 5 plus 1. All of you agree? But please see, we have proved only one thing. We have proved that mod of z is less than equal to root of 5 plus 1. But that does not mean that mod of z can take this value. You're getting my point? Say for instance, I say that no student in your class will have a height of more than 200 centimeter. That does not mean that the maximum height is 200 centimeter. Isn't it? Maximum height will be that which is attained. Okay. Say for instance, the tallest student in your class is of height 163 centimeter. Then you will say that maximum height is 163 centimeter, not 200 centimeter. Is it okay? So whenever you have such a question, you must verify that that value is attained. Attained means you must be able to give one value of z for which this is going to happen. Is it okay? You must be able to give one value of z for which this is going to happen. You're getting my point? See, I repeat. By writing that mod of z is less than equal to root of 5 plus 1, we cannot say that mod of z will maximum possible value is mod of maximum possible value of mod of z is root of 5 plus 1. We must be able to pinpoint one z for which they will coincide. Maximum. Okay, otherwise we can say mod of z will not exceed this, not maximum value is this. But fortunately for us, that if we take z is equal to root of 5 plus 1, then this value will be satisfied. Okay, this equation will be satisfied and mod of z will be equal to root of 5 plus 1. Okay, I leave that part for you. But what will be the minimum possible value of z? Yes? 1 minus? But 1 minus root 5 is negative. Mod of z is never negative. Yes? You getting my point? 1 minus root 5 is negative. Mod of z is never negative. So by merely looking at it, you cannot say that mod of z is going to be, minimum value is going to be 1 minus root of 5. Okay? But I'll not answer this question. I'll leave it for you. You can think about it. Okay? What is the minimum value? It will never be attained. Okay? There is no value of z for which this will be a minimum x. Mod of z will be minimum. Okay? I'll leave it for you because I have to come to other questions. Why x is less than equal to mod of x? Now here is a question from online. Why is x less than equal to mod of x? See, you can have two things. You're taking x to be real number. Such a thing is not valid in case of complex number because no inequality sign is valid in case of complex number. But I am saying x is less than equal to mod of x for x real. There are two things about x. It can be 0, positive or negative. In case it is negative, minus x, that means say x is equal to minus 3. Minus 3 is less than equal to mod of minus 3, that is 3. Isn't it? But if it is 0, then both of them will coincide. If it is positive, both of them will coincide. So we can certainly say that x is less than equal to mod of x. Is it okay? Other thing which you must remember is that if x belongs to R, then what is mod of x? It is equal to maximum of x minus x. Use that. Okay, mod of x is equal to maximum of x and minus x. Use it. You will be getting this inequality holds. Any other? Okay, let's go to the next thing. All right, we'll return to this question. We'll go to the theory first. Please, इसको हटा दीजिए question. इसको हटा दीजिए. Question number 6 पर वापस आ जाइए. मेरे को कुछ theory explain करनी है. उसके बाद पूछेंगे इनसे question. Now, we'll be returning to that question number again. Question number 8. Here is a question for you. That question is. एक मिनट पहले थोड़ी थ्योरी एक्सप्लेन कर देते हैं. थ्योरी पे आ जाइए प्लीज आप. कंजुगेट, इसके बाद ना ज्योमेट्री ऑफ कॉम्प्लेक्स नंबर होगा. क्वेश्चन से एकदम इसके बाद ज्योमेट्रिकल रिप्रेजेंटेशन ऑफ कॉम्प्लेक्स नंबर. इससे नेक्स्ट पीपीटी पे आ जाइए. इससे नेक्स्ट और भी आगे चले जाइए प्लीज फर्दर. हाँ, यहाँ पे some important geometrical results and equations. I've already told you about the distance formula. You know that if you have 2 points AZ1 and BZ2, then the distance between A and B is mod of Z2 minus Z1. Okay. Now, what is section formula? Whatever you studied in coordinate geometry will be translated to complex number. Okay. You given 2 points AZ1, BZ2, and P is a point which divides it in the ratio m is to n. Then what are the coordinates of point P? Coordinates of point P are going to be, that is complex number Z, that will be equal to mz2 plus nz1 over m plus n. See, the same which you studied in coordinate geometry. mx2 plus nx1 divided by m plus n. m by 2 plus n by 1 divided by m plus n. mx2 plus nx1 divided by m plus n plus I times m by 2 plus n by 1 divided by m plus n. Translated to that, it will become this. Okay. Midpoint formula, simple. This is going to be half of z1 plus z2. Okay. Comfortable? Now here is a question for you. You are given that these complex numbers minus 1 plus 3i, b is minus 2 plus 5i, and c is 7, and d is a is minus 1 plus 3i, b is 2 plus 5i. एक minute, I'll have to change d. Sorry, d will have to be changed. Yes, you're given these points: a of x minus 1 plus 3i, b 2 plus 5i, c is 7 plus 5i, d is 4 plus 3i. We wish to show that ABCD form a parallelogram taken in order. Okay, how will you do it? You please tell me. You try it and tell me how will you reach. How will you show that ABCD forms a parallelogram? Very good. What else? If you prove that the opposite sides are equal, then you will be reaching that it's a parallelogram. Any other method which you can think of? Yes, be loud. No, in parallelogram distance diagonals are not equal. Okay, she says what bisecting? Okay. No. Parallelogram, no perpendicular bisector. You're right. Think little. All right. Let me answer this one by one. You said we show that the opposite sides are equal. See, when you are in coordinate geometry, you can do it. Okay, you can do it when you are in coordinate geometry. But when you are in 3 dimension, that method is bound to fail. Okay, if you are in 3 dimension, that method is bound to fail. Look at it. You take a regular tetrahedron. Say something like this. It is a tetrahedron. I take this as point A, B, C, D. You're saying that the opposite sides are equal. Regular tetrahedron hai. Okay, this is the regular tetrahedron. Look at it. Are you having that AB is equal to CD? Because it's a regular tetrahedron, that all sides are equal, isn't it? AB is equal to CD. Are you having that AD is equal to BC? Because it's a regular tetrahedron. But this is not a parallelogram. So the method of showing opposite sides, that's not going to work. In 3 dimension, 2 dimension, it's okay. All right. The best thing to do is you show that diagonals bisect each other. Is it all right? Best thing to do is show that diagonals bisect each other. All right, as she said. Okay, but nothing else is to be shown. Diagonals bisect each other and we are through. What is the midpoint of AC? Three plus 4i. What is the midpoint of BD? 3 plus 4i. Is it okay? Since the midpoint of AC is equal to the midpoint of BD, that means ABCD is a parallelogram. Finished. Nothing else to be shown. All right. Can we have the next PPT, please, in this? All right. Here are what we have to do. Conditions for non-collinear points AZ1, BZ2, CZ3, DZ4 to represent vertices of parallelogram. The diagonals AC and BD must bisect each other. That is the only thing which you have to do. Next is, how will you show that it is rhombus? For rhombus, first, what is a rhombus? It is a parallelogram in which all the 4 sides are equal. In fact, minimum to be shown is Diagonals perpendicular to each other. All right, very good. But see, if you show only this much, that ABCD is a parallelogram, that is diagonals bisect each other. Second thing which you show is that two of the adjacent sides are also equal. That will work, because if you show that this side is equal to this side, you know that this and this sides are equal, this and this sides are equal. You have shown that these two sides are also equal. That means it's a parallelogram in which all the four sides are equal. So it must be a rhombus. Okay. All right. Go to the next PPT, please. Square is very much a rhombus. Converse is not. Okay. Yes. Here it is. All right. For a square, you have to show that the diagonals AC and BD bisect each other, and a pair of adjacent sides are equal. For instance, you can show that AD is equal to BC, and you also have to show that the diagonals are also equal. That is, in square, you have one additional thing. It is that diagonals are also equal. Okay. All right. Rectangle, what it is? It is parallelogram and the diagonals are equal. Finished. That will work. Okay. Can we have the next one? Now, here is a summary. All right. Here is a summary which showing that four non-collinear points form a parallelogram, rhombus, square, oblique, rectangle. Given four non-collinear points A, B, C, and D, diagonals AC and BD bisect each other. It's equivalent to saying that ABCD is a parallelogram. All right. And if you show from here after this that diagonals AC and BD are equal, that means it must be a rectangle. Please see, the things are following from here. It is here, here, then you'll be getting it is a rectangle. And if it is that from here you are able to show that adjacent sides are equal, then you will be getting that ABCD is a rhombus. All right. And if you are getting that all these three conditions are satisfied, this, then it is a square. Okay. This is what we have to do. All right. Now you please go to question number 8. Question number 8 था शायद. Yes. If complex numbers Z1, Z2, Z3 are vertices of एक minute इससे पहले question 7. Yes, question 7. Thank you. Sorry. The points Z1, Z2, Z3, Z4 in the complex plane are the vertices of a parallelogram taken in order if and only if what happens. B part, Z1 plus Z3 must be equal to Z2 plus Z4. There we are. Okay. So we don't have to do anything. So sometimes the question is that you are given points Z1, Z2, Z3 and you are asked to find out what is point Z4. What is point Z4? Z4 will be equal to what? Z1 plus Z3 minus Z2. If Z1, Z2, Z3, Z4 form vertices of a parallelogram, then what is Z4 is equal to? Z4 will be equal to Z1 plus Z3 minus Z2. So in fact, what we can do is we can find out any vertex given other three vertices, provided we are given that four vertices are forming a parallelogram. Is it all right? All right. Let's go to the next thing. Question number 8. Yes. If the complex numbers Z1, Z2, Z3 represent the vertices of an equilateral triangle, and you are also given that mod of Z1 is equal to mod of Z2 is equal to mod of Z3, then which one of this is going to be true? Okay, think. Yes. How did you reach A? No, complex numbers equal हैं ये कैसे कह सकते हैं आप? Okay, हाँ. See, Problem is that if you take z1, z2, z3 equal to 0, first is you will be getting a point, no equilateral triangle, isn't it? Secondly, if you take z1, z2, z3, all of them to be 0, all the four conditions are satisfied. Sorry, first A, B, C, D, A, B, C, all of them are satisfied. So why we should take only A? But you cannot take them 0. Think something else. You given that mod of z1 is equal to mod of z2 is equal to mod of z3. All right. If you given that mod of z1 is equal to mod of z2 is equal to mod of z3, let's say that this is equal to r. Let's say some real number, and it cannot be 0. Okay. If you say that mod of z1, mod of z2, mod of z3, this is equal to r, that means what you have that z1, z2, z3 lie on a circle of radius r with center at the origin. Can you do that? z1, z2, z3 lie on a circle whose center is at the origin and radius is equal to r. No problem? All right. That is, you have some equilateral triangle like this. Okay. Now, what is circumcenter of this triangle? Origin, isn't it? Because your z1, z2, z3 are lying on circle. So its circumcenter is going to be the origin. What is centroid of this triangle? नहीं, centroid कैसे निकालते हैं? Centroid कैसे निकालते हैं आप? Is it okay? This is centroid. In an equilateral triangle, centroid and circumcenter coincide. Isn't it? In an equilateral triangle, centroid and circumcenter coincide. Since they coincide, that means this should be equal to 0. So z1 plus z2 plus z3 is equal to 0. Is it okay? Once again, see, what we do is, we take mod of z1, mod of z2, mod of z3, that is equal to r, say. All right, that means z1, z2, z3, they lie on a circle of radius r and center at the origin. Circumcenter of such a circle is origin. Centroid of this triangle, circumcenter of this triangle is origin. Centroid of this triangle is 1 by 3 z1 plus z2 plus z3. Because it happens to be an equilateral triangle, you have centroid, in center, orthocenter, and circumcenter. They will coincide. That means centroid and circumcenter must coincide. Therefore, z1 plus z2 plus z3 must be equal to 0. So you have this. Is it okay? All right. Have a question?
Sir, can we prove this by showing that slopes of opposite sides are same?
Kisko?
Just before you explain some
Parallelogram. Because the problem is, the question which has been asked is this: can we show that opposite sides have the same slope? But the problem is how we have not defined slope in case of complex numbers. Okay, we have not defined slope in case of complex numbers, and that will require, otherwise also in coordinate geometry, that will require calculating four slopes. You calculate the slope of AB, you calculate the slope of CD, show that they are equal, then you calculate the slope of AD and BC and show that they are equal. Whereas simplest thing to do is midpoints are equal. Midpoints are the same. All right? Yes. Next question. This is suppose Z1, Z2, Z3 are vertices of an equilateral triangle. Once again, it's an equilateral triangle, which is inscribed in the circle mod of Z is equal to 2. You're given that Z1 is equal to 1 plus root 3i. You are interested in finding what is Z2 and Z3. कुछ किसी जगह वीडियो की प्रॉब्लम चल रही है, उसमें आ रहा है वीडियो नहीं, एक्चुअली अभी थोड़ी देर पहले ये आ रहा था कि वीडियो की प्रॉब्लम है किसी जगह. All right. First is you observe that Z1 satisfies this condition. Does it? 1 square plus root 3 square. That is 4. Root ले लेंगे आपके पास 2 आ जाएगा. Okay. Now let's look at this. You have, this is 2. This is minus 2. Anyway, what is 1 plus root 3i? Where is point 1 plus root 3i? It is here on the circle. Is it okay? Now you please, this is point Z1. What is this angle? Yes, 60 degree, pi by 3, isn't it? This angle is pi by 3. What is circumcenter of, because you have that Z1, Z2, Z3 all lie on a circle, that means circumcenter is this. Is it okay? Please observe. Next point will be 120 degree away from this. Isn't it? Next point will be 120 degree away from this. Is it okay? Look at it. If you look at an equilateral triangle with circumcenter this, then observe that This angle is 120 degree. This angle is 120 degree. This angle is 120 degree. This happens only in case of equilateral triangle. Okay. Now, observing that, we can write this. Look, this is pi by 3. This is 120 degree. That means this total will become 180 degree. Next point should be minus 2. Isn't it? Next point should be minus 2. What about next point? Minus 1. Minus 1 plus root 3i. That means you're saying that should be here. Minus 1 plus root 3i कहां पर होगा? Minus 1 root 3i यहां पर होगा. वो नहीं होगा. आप पाई बाय 3 तो पहले चले थे, पाई बाय 3 और चलिए, नीचे आ जाइए. 1 minus root 3i. Is it okay? See once again, see, we make use of geometry. When we make use of geometry, observe that the angle between the angle subtended by a side at the circumcenter is 120 degree. We make use of that. Simply, this angle is pi by, we have found that this angle is pi by 3. We take another 120 degree angle. When we take another 120 degree angle, 60 degree plus 120 degree will make it as, it will make it as 180 degree. That means the next point should be minus 2. All right. We could have come like this. We make 120 degree here. 90 plus 30 will be reaching this point. 1 minus root 3. Alternatively, we could have started from here and come clockwise 120 degree. Okay. We'll be getting the point is 1 minus root 3i. You can now check once again that we have reached a correct answer. What is the distance? We have found the points to be, कौन-कौन से points आए? A answer आ गया ना? You have what is 1 minus root 3i difference between these two. What is the distance between these two? That will turn out to be how much? 1 plus root 3i minus 2. What is that? 3 plus root 3i. उसका मॉडुलस कितना आ जाएगा? 9 plus 3, 12. Root of that will be 2 root 3. Isn't it? Calculate. Rest of them will be all 2 root. Okay, you have reached an equilateral triangle. Okay, but have you understood this method? Can we go to the next thing? All right.
Please just explain that how is the angle equal to 60 degrees in ninth question?
Ninth question. We'll have to go to the question number 9. अच्छा, क्वेश्चन नंबर 9 तो डिस्कस ही नहीं करा अभी हमने. अभी करा नहीं क्वेश्चन नंबर 9. How is that angle 60 degree? In this question, na? Okay. Yes. How is this angle 60 degree? This is 1 plus root 3i. Look here. 1 plus root 3i means the coordinates of this point are 1 comma root 3. All right. Coordinates of this point are 1 comma root 3. When the coordinates of this point are 1 comma root 3, that means what you have is this distance is root 3 and this distance is 1. What should be this angle? Tan. You can calculate tan of theta. Tan of theta is root 3 by 1. Tan theta is root 3. Theta is pi by 3, 60 degree. Okay. This is how we have calculated. All right. Okay, can we go to question? अच्छा, question 9 अब अवॉइड कर देते हैं. Question 11 पे आ जाइए प्लीज. तो अच्छा, question 11 अब थोड़ा सा आगे चलते हैं क्योंकि because we are कम मॉडुलस पे बहुत ज्यादा क्वेश्चन हो गए. Okay, what about this? What is the minimum value of this? We are given. You wish to find out minimum value of the expression mod of z plus mod of z minus 2i. देखिए, I told you this earlier also that whenever you say that minimum value is this, means you must be able to tell one point where that value will be attained. You getting my point? We must be able to tell the point where that value will be attained. So when you say anything, you must make sure that you are able to tell me at least one point where that value will be attained and justify that it is minimum. Okay, you recall this thing that u mod of z1 plus mod of z2, this is less than equal to mod of z1 plus mod of z2. This you know. All right. Look at this. You have mod of z plus mod of z minus 2i. Can you write it as mod of z plus mod of 2i minus z? If I multiply inside by a negative sign, modulus will not be affected. Comfortable? Okay. Modulus of z plus modulus of 2i minus z. Is that all right? Now use it. What is this equal to? Mod of 2i. What is that? Mod of 2i. Does it require any calculation? It is 2. You put 2 outside, mod of I is 1. Is it all right? You put 2 outside and mod of I is 1. This is 2. You get mod of z plus mod of z minus 2i is always greater than or equal to 2. That means minimum possible value can be 2. But where is it attained? कहां पे मतलब z2 कहां पे आ सकते हैं इसकी वैल्यू? 0 पे. Isn't it? If you take z is equal to 0, you will be getting that the value 2 is attained. For z is equal to 0, this expression is taking value 2. Is it taking value 2 for z is equal to 2i? Think. Put 2i here, 2i here. This is 0. Isn't it? It is taking mod of 2i plus 0, that is again 2. In fact, what happens is that you take any point, on this segment 0 to 2i. You take any point on this segment 0 to 2i, you will find that the value will turn out to be 2i. Sorry, value will turn out to be 2. Okay, for instance, I can give you one example. If you take z is equal to I, what happens? Are you getting the value 2? Isn't it? See, you're getting value z, for z is equal to I, you are also getting value 2. That means this expression takes value 2 for infinitely many values of z. See, you can get two types of question. One is find the minimum value of this expression. All right. Other is number of values of z for which this expression will be minimum. Number of values will be infinite and minimum value is 2. Okay. All right. Can we go to the next thing? Okay. Question 13. You have, if Z1 and Z2 are two complex numbers, say that mod of Z1 minus mod of Z2 over mod of Z1 plus Z2 is equal to 1. Then what can you say about X relationship between Z and Z1 and Z2? Very good. Then no, if you please see, she's suggesting that we do this. That is, we transfer. You're saying this. You're saying this. Good. Then what is the square of this? Z1 minus Z2. How much? Yes, please say again. Hmm? Can you write it and show it to me? Show it. But how does this help us? Hmm? See, the problem is that if you expand it, you will be getting here. Please look at it. If you expand it, I'll be telling you other method. I'm just going by the method she said. Z1 square plus Z2 square minus Z1 Z2 bar minus Z1 bar Z2, that is equal to mod of Z1 square plus mod of Z2 square plus Z1 Z2 bar minus Z1 bar, sorry, plus Z1 bar Z2. This is you get. This is what is when you expand it. All right. You can cancel these two. All right. You can cancel these two expressions. What you're left with? You're left with 2 times Z1 plus Z2 bar plus Z1 bar Z2, that is equal to 0. You can remove this 2. All right. You get this, isn't it? You get Z1 into Z2 bar plus Z1 bar into Z2, that is equal to 0. Okay. But we are interested in getting one of these options, or we must be able to tell, okay, none of this is true. From here, can you do that? नहीं कर सकते हैं, आप बताइए कैसे करेंगे. All right, look at it. See what you do. What you do is you divide this entire expression by, say, mod of Z2 whole square. Okay, you divide this entire expression by mod of Z2 whole square. If you divide this entire expression by mod of Z2 whole square, what are you going to get? Will you be getting Z1? Please see, I'm dividing by mod of Z2 whole square. That is equal to Z2, Z2 bar. Okay, that means I'll be getting here Z1 by Z2 plus Z1 bar by Z2, that is equal to 0. Isn't it? No problem. What does it give you? Does it give you that Z1 by Z2 should be imaginary? Does it give you that Z1, Z2 should be imaginary? What is real Z? Recall, real Z is what? Half of Z plus Z bar. Isn't it? But I'll tell you a simpler method. Don't worry. I'm going by the method she suggested. I'll tell you a very simple method. Okay. You have here Z1 by Z2 plus Z1 bar by Z2 bar. Sorry, this is Z2 bar. Sorry. This is equal to 0. This gives you that this implies real Z1 by Z2 that is equal to 0. It means what? Z1 by Z2 must be equal to some ik. Isn't it? Z1 by Z2 must be equal to some ik. That means this is the option. Is it okay? But please see, we don't have to do it. We have a very simple method of doing it. All right. You are given this. Okay, you are given this. Can you say that can you say this? All right. Of course, we are ruling out the possibility that Z2 could be 0. Okay. Does it mean that Z2 and Z2 by Z1 is equidistant from -1 and 1? Does it say this? Does this equation say that Z2 by Z1 is equidistant from 1 and -1? When you say that Z2 by Z1 is equidistant from -1 and 1, where it should be? On the imaginary axis. Isn't it? It should be on the imaginary axis. So you got Z2 by Z1 is imaginary. That is Z2 must be equal to ik Z1. All right. So we don't have to square that and do that. All right. Okay. Yes. Let's. अच्छा क्वेश्चन नंबर अब नेक्स्ट पे आइए प्लीज. अच्छा इसको भी स्किप कर देते हैं अभी. We have lot of things. अच्छा this question we have already discussed. Look at this. I've already told you how to do it. Read the question. I've already told you how to do it. If Z belongs to C, minimum value of mod of Z plus mod of Z minus 1 is attained at how many points? अभी थोड़ी देर पहले बताया मैंने. Infinite number of points. All points with from the on the segment 0 joining 0 to 1. Okay. All points you will be getting the minimum value. Go to the next one. Okay, but before we can come to question number 16, we'll discuss the concept of argument. Then we'll return to this question. See, first is argument of a complex number is defined for Z not equal to 0. For 0, Z is equal to 0, we don't have any argument. Okay. Now, what you have to do is, if this is x-axis, y-axis, you write Z is equal to x plus iy. All right. You write Z is equal to x plus iy. If you write Z is equal to x plus iy, and you're saying that Z is not equal to 0, it means at least one of xy should be different from 0. Is it okay? At least one of xy should be different from 0. How do we define argument of Z? What is argument of Z is, that is, see what you do is, you take Z, all right, you take Z on the complex plane. It will not coincide with 0 because you have taken it to be different from 0. What you do is, you join 0 and Z. All right, you join 0 and Z. Now, what is argument of Z? Argument of Z is the angle. Argument of Z is the angle by which we must rotate x-axis to coincide it with OZ. Is that all right? The least angle by which we must rotate the real axis to coincide it with OZ. All right. If you have that it is in the first and second quadrant, you will go counterclockwise. And if you are in the third, or fourth quadrant, you will go counterclockwise. Okay, that means if you are in the first and the second quadrant, your argument z will be positive. Okay, and if you are in the third, fourth, and third quadrant, your argument z will be negative. Okay, this is one thing which you must remember. Now see, that means argument of z will always lie between fundamental. And please see, we can take any interval of 2 pi for argument. We can take any interval of 2 pi from argument. And unfortunately, there is no unanimity in the literature regarding fundamental argument. Some books take it from 0 to 2 pi. Some books take it from minus pi to pi. But what we are going to do is we'll be restricting ourselves from minus pi to pi. Okay. And most of the questions, I'll say that in the 40 years questions, last 40 years question, which I have seen, they have always taken the argument from minus pi to pi. Okay. So your argument will be from minus pi to pi. All right. You have argument of z, maximum possible value is pi and minus pi. But please see, minus pi will never be attained. ठीक है, माइनस पाई जो है वो कभी भी अटेन नहीं होगा. ऑलराइट, पाई विल बी अटेन, माइनस पाई विल नॉट बी अटेन. Is it okay? Because the problem is that if you take any point here, say I take minus 5. What is argument of minus 5? Yes, argument of minus 5 is, it is going to be pi. All right, argument of minus 5 is pi, not minus pi. You cannot come from this side. For negative real axis, you will go from this side to minus side of x-axis. Okay, and it is going to be pi. Argument of minus 5 is pi. Is it okay? It is not minus pi, remember that. All right. Now you tell me what is going to be argument of z bar in terms of argument of z. Think very simple. अगर आपके पास ये z है, z बार कहां पर होगा? यहां पे, isn't it? It is this is z bar. That means argument of z bar is minus times argument of z. All right. Okay. All right. What is, you tell me what is argument of 2? If you take argument of z1 into z2, what is going to be that? Yes, argument of z1 plus argument of z2. All right, argument of z1 into z2 is argument of z1 into, sorry, plus argument of z2. But it can happen that they differ by a multiple of 2 pi. The two sides may differ by a multiple of 2 pi. It can happen. Okay. Now I tell you why. See, you said what you said was this. This is I say that you must add this thing, where k is 0, 1 or minus 1. Okay, this is a safe thing. Let me tell you, let me give one example. Let's take z1 is equal to minus 2. All right, let's take z1 is equal to minus 2 and z2 is minus 3. All right, let's take z1 is minus 2 and z2 is minus 3. What is left hand side? You're taking z1 is now what is left hand side? If you take the product, argument of what is that? No, think again. 0, because it will be on the real axis, isn't it? You have argument of 6 is 0. Any point which is on the positive side of x-axis, its argument will be 0. Okay, that means left hand side becomes 0. What about the right hand side? What is the argument of z1? Minus pi, sorry, pi. Thank you, pi. And what about argument of z2? Pi. Whereas left hand side is 0, right hand side is 2 pi. That's why we have to add a factor of 2k pi. Okay, so argument of z1 into z2, that is equal to argument of z1 plus argument of z2 plus 2k pi, where k is a number bit either 0, 1 or minus 1. All right. Now, similarly, you have what about argument of z1 by z2? This will be replaced. This is argument of z1 minus argument of z2. Yes. Is that all right? No, we must again add a factor of 2k pi. Okay, we must again add a factor of 2k pi. All right, plus 2k pi. For safer side, you always must do that, where k takes once again the value 0, 1 and minus 1. Okay, what is argument of z square? Two argument of z. Use this. Take z1 is equal to z2. You get argument of z1. Argument of z1 into z2 is this. You take z1 is z, z2 is z. That becomes z square. Right hand side will be twice of argument of z. Can we have the theory part? We have some something to explain there. नहीं तो सारा लिखना पड़ेगा. इससे पहले इससे भी पहले आ जाइए. Okay, please come to that. Some important results involving argument of z. If z, z1, z2 are non-zero complex numbers, you have argument of z bar is minus times argument of z, that we have already seen. Argument of z1, z2, that I've already explained, that it will be argument of z1 plus argument of z2. In fact, we must have this, and where k is this. Argument of z1 into z2 bar, that will be argument of z1 minus argument of z2. Okay, we are using the two previous results. Argument of z1 by z2 is this. Next PPT, please. All right. And once again, they may differ by 2 pi. Now, please see. We have some results which you must remember. I'll explain them one by one, but you must remember these results. Mod of z1 plus mod of z1 plus z2 is equal to mod of z1 minus z2, provided their argument differ by pi by 2. Okay, plus minus pi by 2, that is minus pi by 2 or plus pi by 2, but they differ by a multiple of odd multiple of pi by 2. z1 plus z2 is equal to mod of z1 plus mod of z2, that is equivalent to say that argument of z1 is equal to argument of z2. Okay, and similarly you have mod of z1 z2 whole square is equal to this, that is z1 square z2 square 2 mod of z1 z2 into cos of theta 1 minus theta 2 etc etc. इसके बाद भी कोई पीपीटी है, एक मिनट देखना आर्गुमेंट के बारे में नहीं, ठीक है. नाउ लेट मी एक्सप्लेन अ फ्यू थिंग्स मोर. See, what you do is that you given two complex numbers. One is z1, other is z2. All right. You complete a parallelogram using this. What you're going to get? You will be getting here. You will be getting this. This is O, this is A, this is let's put it as C, and this is B. Can you tell me what are the coordinates of point B? They should be coordinates of point B कितने? Parallelogram complete करा आपने. Coordinates of point, affix of point B. What will be the affix of point B? Z1 plus Z2. Is it going to be Z1 plus Z2? Check. देखिए, let me tell you how. you have what is midpoint of AC? Midpoint of AC is what? Z1 plus Z2 by 2. Midpoint of OB should also be Z1 plus Z2 by 2. So you should have B should be equal to, a fix of B should be equal to Z1 plus Z2. Is that all right? Now you see one more thing. What is going to be this diagonal OB? What is the length of this diagonal? Is it equal to this? Isn't it? Length means you take the modulus. Okay? Length means you take the modulus. Now, under what circumstances you will be having that mod of Z1 plus Z2 that is going to be equal to mod of Z1 plus Z2? When? आर्गुमेंट पे नहीं जाइए, वैसे इसमें देखते हैं. ठीक है, लेट्स विल गो टू आर्गुमेंट लेटर ऑन. See, you have, that means what must happen is OA plus AB, that should be equal to OB, isn't it? That is the thing you are saying. It means Z1 and Z2 must lie on the same line passing through the origin and on the same side of the origin. Is it okay? That is, your situation is like this. This is O, this is Z1 and Z2. The Z2 is somewhere here. Z1 plus Z2 is like this. All right. It's like this. It is a situation like this. That is, what's going to happen is that this length will be equal to this length plus this length, provided they lie on the same side, on the same line, and on the same side of the origin. Okay. They must lie on a line joining Z1, O and Z2 and on the same side. If they are on the opposite side, then such a thing will not be valid. Now you can look at it. What is this? Argument of Z1 must be equal to argument of Z2. Okay. So you have mod of Z1 plus Z2 is equal to mod of Z1 plus mod of Z2, provided argument of Z1 is equal to argument of Z2. All right. Other thing which I told you was this, जो कि पीपीटी में था, ये आपके पास, when is this going to happen? क्वेश्चन, क्योंकि ये कॉन्सेप्ट मुश्किल है. When is this going to happen? Think. क्या है क्वेश्चन? Modulus prove that modulus of real mod of real z plus mod of z is less than or equal to 2 times root 2 and mod of z. Okay. Yes. When is it going to happen that mod of Z1 plus mod of Z2 is equal to mod of Z1 minus Z2? Very simple. You just concentrate on this parallelogram. What is mod of Z1 plus Z2? It is equal to OB, isn't it? All right. What is mod of Z1 minus Z2? This is equal to AC, isn't it? What does it mean? It means that this has become a rectangle, isn't it? It means that this has become a rectangle. That means argument of Z1 and Z2, they must differ by pi by 2. Is it all right? Argument of Z1 and argument of Z2, because in that case, this angle will become pi by 2. Is it okay? So you will be getting that if you have mod of Z1 plus Z2 is equal to mod of Z1 minus Z2, then argument of Z1 minus argument of Z2 or argument of Z2 minus argument of Z1, that should be equal to pi by 2. All right. I'll be coming to that question in a minute. If Z1 and Z2 are two non-zero complex numbers, say that mod of Z1 plus Z2 is equal to mod of Z1 plus mod of Z2, then argument of Z1 minus argument of Z2 should be equal to 0. अभी तो बताया बेटा. They must lie on the line joining 0, Z1 and Z2 and on the same side of the origin. ठीक है? So don't require any proof. All right. This is the question from IIT entrance examination. Okay. Argument mod of Z1 plus Z2 is equal to mod of Z1 plus mod of Z2. provided argument of z1 and z minus argument of z2 that is equal to 0. अच्छा एक मिनट नेक्स्ट पीपीटी भी देख लें उसके बाद आई कम टू दैट क्वेश्चन. हाँ एक ये भी नहीं हो पाएगा क्योंकि इसके अंदर यू हैव नॉट रेड द कंसेप्ट ऑफ इनवर्स ट्रिग्नोमेट्रिक फंक्शंस एज यet. ऑलराइट लेट्स लीव दैट क्वेश्चन. Okay, we'll be coming to that question. There is a question which has come online. The question is, sir, please prove that real z. The question is this: mod of, if you take z is equal to x plus iy, then this is less than, एक minute, less than equal to x. Yes, we wish to prove this. Yes, you have mod of x plus mod of y that should be less than equal to 2 times root of x square plus y square. How can you prove it? Squaring both the sides. See, the simplest thing to do is, let's consider the square of this minus square of this. All right, you have 2 times x square plus y square minus this. Let's consider this. What is this equal to? You remember that x and y are real numbers. Xy belong to R. All right, what is this equal to? X square. This is, please expand this. What do you get? X square plus y square plus 2 times mod of x mod of y. That is equal to what? X square plus y square minus 2 mod of x into mod of y. This is equal to what? This is, can you write it as mod of x minus mod of y whole square, that is greater than or equal to 0? That proves it. Is it okay? You have twice of x square plus y square minus this is greater than or equal to 0. That means this expression is greater than or equal to this expression, which will give you this. Okay? और तो नहीं है कोई? आइए, please come to this question. You have the question number. Question is, if A, B, C are integers not all equal and omega not equal to 1 is the cube root of unity, then what is the minimum value of this expression? somehow we must get rid of omega, isn't it? Somehow we must get rid of omega. Then we shall have to deal with real numbers. Yes. What is the best way to get rid of omega? Multiply by omega, but how does that help us? But then if you multiply this entire expression by omega, this will be of course 1. But then you will be having omega square here and omega here. All right, let's do one thing. Let's put this expression equal to, say, d or anything. Say, let's put it equal to x. This is a plus b omega. Can you write it as like this? You recall what is omega square? Omega square is minus 1 minus omega, because 1 plus omega square is 0, isn't it? So you can write it like that. That means this is equal to what? This is equal to a minus c plus b minus c omega. What is x square? X square will be how much? X square is, remember that these are ABC are integers, that you must remember. Now, what is this equal to? Is it like that? No problem with that? You have this is equal to, see what you do is, if you are taking x square means you multiply x and x bar, isn't it? You multiplied x multiplied by x bar. Okay, but what is omega bar equal to? Very good. It is 1 by omega. 1 by omega is nothing but omega square, isn't it? You see that you recall what is omega. Omega is minus 1 by 2 plus root 3 by 2i. When you take omega bar, it will be minus 1 by 2 minus root 3 by 2i. That is nothing but omega square. Okay. So you will be getting that this is equal to this thing, a minus c whole square plus b minus c into omega, b minus c square omega omega bar plus, look at it. Now tell me, is it okay? Check and tell me. We have multiplied out the entire expression. Comfortable with this? What is omega into omega bar? What is omega bar you told me? 1 by omega cancels. You're left with 1. Isn't it? You're left with 1. All right. What is omega plus omega bar? Omega plus omega bar. That will be omega plus omega square. That is minus 1. Isn't it? That is minus 1. So you'll be getting that this is equal to a minus c whole square plus b minus c whole square minus a minus c b minus c. Is it okay? Now our problem now reduces to finding the minimum value of this expression. As I said that we must try to eliminate omega. We have eliminated. We must try to find out what is the minimum possible value of this expression. Okay. Now What about this? How can you write this? Let's simplify this, and please simplify yourself and tell me whether you're getting this or not. Simplify this entire expression and tell me whether you're getting this expression or not. Yes, all of you getting it? Very good. Now, please see, this will be very useful to you people. Can you write it as can you write this expression like this? What you do is you multiply the entire expression by 2, okay, and divide by 2. You'll be getting that this twice of this expression becomes what you have written in the bracket. No problem. Now, what you're given? ABC are integers, not all equal. Okay, ABC are integers, not all equal. That means I say that at best one of them can be 0. Okay, two of them cannot be 0. At best one of them can be 0. Let's say that two of them becomes 0. All right, let's say that two of them becomes 0 from here. That is, you say that A minus C becomes 0, B minus C becomes 0. If A minus C is equal to 0, B minus C is equal to 0, you will be getting that A is equal to B is equal to C, violating this condition. Okay, that means at least two of them have to be different from 0. We are interested in what? We are interested in obtaining the minimum value. We make A minus C 1, B minus C 1, and A minus B 0. Can we do that? All right, we can take A is equal to C plus 1, B is equal to C plus 1. Is that all right? That means we'll be getting the minimum possible value of x square is 1. Isn't it? Minimum value of x square is 1. That means the minimum possible value of x is 1. Is it all right? Once again, see that A minus C, B minus C, A minus B whole square. At best, two of them can be, sorry, at best one of them can be 0. All right? You make, for instance, if I take A minus C 0, B minus C 0, I'll be getting A is equal to B is equal to C, which will violate this condition. Okay? That means what I can do now is I put A is equal to C plus 1, B is equal to C plus 1, and then this will be 1, this will be 1, this will be 0. I'll be getting 1 by 2 into 2, that is 1. That means x square is 1. Minimum value is 1. But what did I tell you? We must verify that there is at least one point where that value will be attained. अब बताइए कहां पे अटेन हो रही है वैल्यू? You have to tell the values of ABC for which this expression becomes exactly equal to 1. Okay, look at it. Take A is 2, B is 1, C is 1. All right, let's take A is 2, B is 1, C is 1. What do you get? If you have that A is 2, B is 1, C is 1, then you will be getting omega plus omega square, that will be equal to minus 1. 2 minus 1 will be equal to 1. So that means for A equal to 2, B equal to 1, C equal to 1, the minimum value will be attained, and that is going to be 1. Right? You can think once again. If you have problem, you can ask it. You can take 1 minute. This is a difficult question. चलिए नेक्स्ट पीपीटी पे आ जाते हैं. इसको स्किप कर देते हैं, हम बच्चों के लिए छोड़ देंगे. All right. If you have seen that, then you please return to this. बताइए. Why should we add 2k pi आर्गुमेंट के अंदर? वो I told them. एक मिनट अब. हाँ, क्वेश्चन बताइए. नहीं, क्वेश्चन नंबर 18 में तो 2k pi की कहीं जरूरत नहीं पड़ी. इन आर्गुमेंट ना, सी I gave one example that argument of z1 z2 is equal to argument of z1 plus argument of z2. Then they may differ by a multiple of 2k pi. That is, left hand side and right hand side may differ by a multiple of 2 pi. Okay. And I gave the example that you take z1 is equal to -2, z2 is equal to -3. All right. You take z1 is equal to -2, z2 is equal to -3. What will be this equal to? Z1 into z2. That will be equal to 6. What is argument of z1 into z2? Because it is, look at it. Your 6 is here, -2 is here, -3 is here. Argument of 6, that is going to be 0. Because in this case, there is no rotation of x-axis. All right. So argument of 6 is going to be 0. Whereas what is argument of z1 plus argument of z2? That is going to be argument of z1 is pi and argument of z2 is also pi, that is 2 pi. Now you look at it, the two things, this is 0, this is pi, this is pi. In this case, we shall take k equal to -1. Balance the two sides. All right. चलिए नेक्स्ट इस क्वेश्चन पे आइए प्लीज. एग्जाम्पल 20 पे. अच्छा, we'll wait for this question. एक मिनट, नेक्स्ट क्वेश्चन पे आ जाइए प्लीज. I'll return to it in a minute. Next. Okay. Question 21. I'll return to question 20. You're given two equations. You wish to find out a simultaneous solution of this system of equations. because we are left with very little time now. Yes. How will you attempt it? Yes, anybody? How do we do it? Hmm? Squaring this one. Okay. What did you reach? See, now one thing, please see. When we give this question in the class, what happens is the student immediately puts z is equal to x plus yi. Square, simplify, then they reach an equation. All right. Please avoid putting z is equal to x plus yi. All right. That should be the last thing in your mind rather than the first. You lose the advantage of complex numbers if you put z is equal to x plus yi. That you should not do it. All right. Let's look at what does this represent. Mod of z 1 minus I is equal to root 2. What does it represent? It represents a circle with center at minus 1 I, isn't it? With center at minus 1 I and radius equal to root 2. Okay. Now look at it. We say that you have minus 1, here is minus 1, here is I. All right, this point is minus 1 plus I. No problem. What is the radius of this circle? Root 2. Is this distance equal to root 2? Ye distance, is it root 2? Distance between the origin and minus 1 and I, is it equal to root 2? All right. If it is equal to root 2, that means it is a circle which is like this. Okay, it is a circle like this. Now, mod of z is equal to 3. What does it represent? It is a circle with center at the origin and radius equal to 3. That means it is going to be a circle like this. Okay. What we are looking for? We are looking for whether these circles intersect or not. Where they intersect, that will be the simultaneous solutions. All right. I've drawn it like this, but it may not be like this. It may happen that the circle is slightly smaller one. It may touch at one point. It may intersect at 2 points. It may not intersect at all. Now we have to justify this. All right. Because they are not asking us what is the solution. They are asking us the number of solutions. Okay. When they are asking us the number of solutions, that means we are interested in finding the point of intersection of these two circles. Okay, let's see about the point of intersection. What is the distance, maximum possible distance on this circle from the origin? Be careful. It is 2 root 2. 2 root 2. Isn't it? Maximum possible distance of any point from origin on this circle is going to be 2 root 2. Whereas this distance is what? 3. All right. Is 2 root 2 smaller than 3? Isn't it? 2 root 2 is smaller than 3. That means these circles cannot intersect. Is it okay? These circles cannot intersect. Since these circles cannot intersect, this system of equation has no solution. Okay. See, please see, what I'm trying to tell you is this, that most of the time we don't require putting z is equal to x plus iy, simplifying, etc., etc. By merely geometric considerations, you can solve. Okay. Now, before I question to before I go further, let's look at what is polar form of a complex number. What is polar form of a complex number is, you take, let z be not equal to 0. All right, let z be not equal to 0. Then what you do is, this is the origin. Let's say that z is here. All right, let's say z is here. And let's say that z is equal to x plus iy. And this angle is theta. And this is r. That is mod of z is equal to r. And argument of z, that is equal to theta. All right, I'm taking the fundamental or the principal argument that is lying between minus pi and pi. Can you tell me what is x is equal to? Can you say that x is equal to r cos theta and y is equal to r sin theta? Okay, what is z? Z is equal to r cos theta plus I sin theta. All right, z is equal to r cos theta plus I sin theta. This is the polar form of complex number z. Okay, that is what you can do is, see, in the literature, you will find that cos theta plus I sin theta, that has been denoted by e to the power of, this is r e to the power of I theta. Okay, in the literature it is denoted like this. There is other notation says theta, but let's say it is ei theta. Okay, now so what you can do is, you can write any complex number in the form mod of z into e to the power of I argument of z. Okay, you can write any complex number in the form z is equal to mod of z into e to the power of I argument of z. That is polar form of the complex number. Okay, you have x plus iy to be Cartesian form, that is the polar form. All right, now you are familiar with what is de Moivre's theorem? What is de Moivre's theorem? Yes. What is de Moivre's theorem? See, you should try to answer the question. The reason is, maximum is, it will be incorrect. Your answer will be incorrect. That is the maximum, but you should try. Come out. What is de Moivre's theorem? Yes. Shall I help you? It says something about this. What is it equal to? Cos n theta. Are you sure? Now, please remember few things. First is, you say that cos theta plus I sin theta to the power of n. This is equal to cos of n theta plus I sin n theta. If n is integer, okay. If you're writing cos theta plus I sin theta to the power of n, that is equal to cos of n theta plus I sin n theta, provided n is an integer. If n is not an integer, say for instance n is equal to 1 by 2 or n is equal to 3 by 5 or minus 3 by 5, then you cannot do such a thing. All right. Please remember, de Moivre's theorem says that cos theta plus I sin theta to the power of n, this is equal to cos of n theta plus I sin n theta if n is an integer. But if n is of the form say if n is of the form p by q, where pq are integers, q is positive, all right, then this will become p by q theta plus I sin p by q theta. Now, but we cannot say such a thing. We'll let me put it like this. See, if PQ are integers and Q is positive, then cos theta plus psi sin theta has many values. Okay, cos theta plus psi sin theta has many values, out of which one will be equal to this. You getting? So, in case of rational numbers, you will say that cos theta plus I sin theta, one of the values of this will be cos of n theta plus I sin n theta. Okay, it is not equal to, it is one of the values. Maybe there are more, but out of which one will be equal to this. All right. Now, other thing. See, cos theta plus psi sin theta to power of p by q. You take pq are integers, q is positive, and you please make one more thing, that pq, that is greatest common divisor, is 1. That is, if you have some common factor, just cancel it. Okay, cos theta plus psi sin theta to the power of p by q. P by q is equal to, where pq are integers, q is not equal to 0, q is positive, and HCF of pq is 1. Then cos theta plus psi sin theta to the power of p by q, it has exactly q values. All right, it has exactly q values, and they are given like this. Oh, sorry. That will be 2k pi plus, we'll have to, I'll illustrate with the example because general thing will become slightly difficult. Say for instance, you are interested in cube root of unity. You can write it like this: cos 0 plus I sin 0. This is equal to 1 by 3. Is it all right? This is cos 0 plus I sin 0. This is equal to 1 by 3. What you do is you write it like this. This is equal to cos of 2k pi plus I sin 2k pi, this whole to the power of 1 by 3. You can say that this is equal to cos of 2k pi plus by 3 plus I sin 2k pi by 3, where k takes three values 0, 1, and 2. Okay, you can take any three consecutive values in the present case. All right, any three consecutive values. If you have n here, then you can take any n consecutive values. Let's see whether we have got the correct thing or not. You already know what are cube roots of unity. What are cube roots of unity? 1 omega omega square, isn't it? Let's say that we take k is equal to 0. If you take k is equal to 0, you will be getting cos 0 plus I sin 0, that will be equal to 1, isn't it? You take k is equal to 1, what are you going to get? You're going to get cos of 2 pi by 3 plus I sin 2 pi by 3. What is cos of 2 pi by 3 equal to? Cos 2 pi by 3, that is minus 1 by 2, isn't it? Cos 2 pi by 3 is equal to minus 1 by 2. I sin 2 pi by 3 is root 3 by 2, isn't it? So minus 1 by 2 plus I root 3 by 2, which you denoted by omega, isn't it? And then next value is cos 2 pi by 3, 4, sorry, cos 4 pi by 3 plus I sin 4 pi by 3. That will come out to be minus 1 by 2 minus I root 3 by 2. Okay, 1 omega omega square. So what did you see is this, that the expression, if you're writing this expression 1 to the power of 1 by 3, it has exactly three values, okay, out of which one will coincide with this, like that. All right, please go to the previous question. Quick question to nahi hai is pe? Yes. Let z and w be two non-zero complex numbers such that mod of z is equal to mod of w and argument of z plus argument of w is equal to pi. Then z is equal to what in terms of w? All right, we have only around 14 minutes left. Let's look at this. What is, you say that mod of z is equal to mod of w. Let's put it equal to r, say. All right, mod of z is equal to mod of w. Let's put it equal to r. What is, let's say we are interested in argument, let's put argument of w that is equal to alpha. All right, let's put argument of w is equal to alpha. Can you say this thing that w is equal to r e to the power of I alpha? Polar form, isn't it? W is equal to r e to the power of I alpha. All right. Now that done, we are interested in z. What is z is equal to? Z is equal to r e to the power of I pi minus alpha. Isn't it? You're given that argument of z plus argument of w is pi. That means argument of z is pi minus alpha. What is this equal to? R e to the power of I pi e to the power of minus I alpha. What is e to the power of pi I? Calculate, simple. Cos pi plus I sin pi. Isn't it? What is e to the power of I theta? E to the power of I theta is cos theta plus I sin theta. In the present case, it will become cos pi plus I sin pi. What is cos pi? Minus 1. Isn't it? That means e to the power of I pi is minus 1 plus 0. 0i. Isn't it? That will be minus 1. All right. That done. This is equal to what? Minus r e to the power of minus I alpha. Can you do that? Check it. Now, final step. Can you write it like this? See, when you take the conjugate means what you do? You change I to minus I. What is this equal to? Is it minus W bar? So what is Z? Minus W bar. All right. See once again. What you have to do? You take, you put mod of Z is equal to mod of W is equal to R. All right. And you take argument of W is equal to alpha. Then write the polar form of W, write the polar form of Z. And try to see what you get. W is equal to R e I alpha. Z is equal to R e to the power of I pi minus alpha. What is that equal to? R e to power of pi I e to power of minus I alpha. And minus R e to power of minus I alpha. And what is this equal to? This is equal to this. All right. See, look here. Let me explain it a little more. Minus R. What is e to the power of minus I alpha? E to the power of minus I alpha is cos of minus alpha plus I sin minus alpha. All right. That will become what? That will become minus R cos alpha minus I sin alpha. Isn't it? And this is nothing but minus R is it okay? That is nothing but W. Okay, minus W bar. All right. Can we go to the next? चलो ऑनलाइन क्वेश्चन ले लेते हैं. क्वेश्चन 5 देखना पड़ेगा. आगे थोड़ा सा. Question 5. Question next. How is okay? You have z square is equal to z bar minus z bar. You take modulus both the sides. If you take modulus both the sides, what you're going to get? Modulus of this is equal to modulus of minus z bar. What is modulus? What is left hand side? Does it become equal to this? And what is right hand side? Does it become equal to this? All right. And what does this give you? Mod of z into mod of z minus 1. That is equal to 0. This implies mod of z is equal to 0 and mod of z that is equal to 1. See, in this case, you're going to get only one complex number, namely 0. But in this case, you can write z mod of z square is equal to 1. That is z bar is equal to 1. This will imply z bar is what? 1 by z. You substitute it in this equation. Z square is minus 1 by z. Okay? अच्छा चलिए और कौन सा क्वेश्चन है? चलिए. Okay, we have time for 5 more minutes. No? We can discuss one more question. All right, let's take question number 22 now. क्वेश्चन 23 पे देखिए प्लीज क्या है. दिस विल रिक्वायर टाइम. ये भी थोड़ा मुश्किल है. अगले देखते हैं नेक्स्ट. ऑल राइट, we've already discussed this question, isn't it? Next. All right, let's go to this question. If z is, I'll discuss two questions quickly. Okay, if z is not equal to 0 is a complex number such that argument of z is equal to pi by 4, then what can you say about the options? You got argument of z is equal to pi by 4. If argument of z is pi by 4, what happens? You can write z is equal to what? Z is equal to mod of z cos of pi by 4 plus I sin pi by 4, square it. What do you get? Z square is mod of z square cos of pi by 2. This will become by De Moivre's theorem. Okay, what is cos of 2 pi by 4? That is cos of pi by 2, isn't it? Cos of pi by 2 आ जाएगा आपके पास. That is equal to mod of z square. Cos of pi by 2 is 0 plus I sin pi by 2 is 1. That means z square is I times mod of z square. So what do you get? Real z square is 0. Okay, you get real z square is 0. All right, next question please. All right, this question. कैसे करेंगे बोलिए? Hurry, please be quick. This is a question from a competitive examination. Okay, let me hurriedly tell you how to do it. See, you got z bar plus IW bar is equal to 0. Z bar plus IW bar, this is equal to 0. Let's take conjugate of this. If you take conjugate of this, what do you get? This is, let's take the conjugate of the entire thing. What do you get? Z plus minus. Okay, that will be Z minus IW. We are not writing. Okay, anyway, omega W, that does not matter. Z minus IW is equal to 0. Is it okay? Now you have what? You got argument. You are interested in argument of z. That means you must get rid of w. What is w is equal to? This implies w is equal to what? Z by I. Pi is equal to what? Pi is equal to argument of zw. That is equal to argument of z square by I. Isn't it? What is this equal to? Twice argument of z minus pi by 2. Check and tell me, is it okay? What is argument of z1 by z2? Argument of z1 minus argument of z2. Use that. You will be getting argument of z square minus argument of I. What is argument of z square? Argument of z square is twice of argument of z. Twice of argument of z. Argument of I is pi by 2. Okay. So you get pi is equal to 2 times argument of z minus pi by 2. What is argument of z? 3 pi by 4. Here you are. Okay. Can we take one more? एक और ले लो हैं 2 मिनट्स ना चलिए एक क्वेश्चन और देखते हैं अरे नहीं ये नहीं होगा 2 मिनट में ये भी नहीं होगा थैंक यू that is the only thing which we can have in 2 minutes thank you if you have any question here you can ask
How are you? You have already had one class on complex numbers or two classes? अच्छा, एक आपकी कल हुई होगी ना कॉम्प्लेक्स की, और एक लास्ट सैटरडे सुबह ही। ओवरडोज तो नहीं हो जाएगी कॉम्प्लेक्स नंबर्स की? उसमें प्रॉब्लम्स किए थे या थियरी ज़्यादा? So, hi friends. So once again we meet for a session on complex numbers. I've heard that you all already had two sessions, and in this year, in your 11th class school curriculum, you have also studied this chapter. So today I focus on a number of problems. In fact, I won't be going into theory. I will directly start with problems, and through problems only we'll try to elaborate some concepts. So I am starting from very basic questions. The questions, if you want to categorize them, they can be questions based on concepts where your conceptual understanding is tested. They may involve a lot of calculation. The calculation again needs that you know the formulae and you know the concepts well. Then, so far as complex numbers are concerned, their geometry is very important. If you can understand how a complex number is there in the complex plane, how lines are represented, how circles are represented, then that geometry will, in a number of questions, will help you a lot in solving the problem without calculating. I will basically be concentrating on conceptual problems, because if there are questions which involve a lot of calculation, those are normal subjective type problems which you must have done in your schools. Then there are problems where you have to know some results. I mean, you can solve it directly, but if they are depending on certain standard results. So my advice would be, you go through every result you have studied, not only in your textbook, but whichever book you are using for preparing your competitive exam for IIT and other engineering entrance examinations. You go through the theory and see which are the important results which you can just keep in memory. Such results have also been listed in your material that have been provided under Udaan. Okay, so let us start straight away with a problem like this, a very basic question. Minus 4 into minus 4 is what? So you can see that minus 4 is 2i. So therefore minus 4 into minus 4 will be 2i into 2i, and therefore it will be 4 iota square, which is minus it, the answer may not be correct here. You can rectify it. No choice is given. It should have the choices have been 4 iota, minus 4 minus 4 iota. This should have been the choices. But the basic question is the one which I have posed here. When is root xy equal to root x root y? When root of x and root of y is equal to x and y. When x and y are both positive, it is always true, because square root of 4 and square root of 9 you can always write as square root of 36, and therefore 2 into 3 is good. If one of them is negative and the other is positive, what happens? 4 and minus 9, again it is true, is it? Let us see what is the result here. This is 2, this is 3 iota, and this is 6 iota. So we can see that when 4 is, this is positive and this is negative. Similarly, if it is minus 4 here and 9 here, the result is minus 36. But what happens to this? Minus 4 into minus 9. Is it equal to square root of minus 4 into minus 9? No, it is not equal. So that means the result root x into root y equal to root xy is true in two cases, when both x and y are positive, or if one of them is negative. At least that means they should have opposite signs, or both of them should be positive. If both of them are negative, the result is not true. So this is to be kept in mind. Otherwise, this first problem I have given, you already knew. So these choices given here are not correct. Had I taken minus 14 here, minus 16 here, and minus 16 here, then one of these choices would have come. Let's see more problems. Which of the two numbers is greater? Can you tell me? 2 plus 3 iota and 3 plus 2 iota. Which one of these two is greater? Have you ever come across such type of question? Have you compared? Let us see. Actually, what happens is, in real numbers, you know that if we have two real numbers, say 2 and 3, we can always compare them. One simple technique is you plot them and see whichever is in the on the right hand side on the number line, that is bigger. They are all lined up. You draw a line, infinite line, take any point as 0. All the numbers on the right hand side are positive, all the numbers on the left hand side are positive. Now whenever a real number is taken, it can be represented on the number line. When two real numbers are represented on the number line, one will be on the right, the other will be on the left, or they will fall at the same point. So if the one on the right is always bigger. But what happens in case of complex numbers? Numbers are not in a straight line. They are scattered all over the complex plane. You know that we call this as the complex plane. So what is the idea of greater or smaller? In the real number, a number was greater or smaller depending on whether it was on the right or on the left of the other number. But here there is no such linearity. Numbers are scattered. Where is the point 2 plus 3 iota? 2 is here. 1, 2, 3, maybe this. This is 2 plus 3 iota. And where is 3 plus 2 iota? In fact, we cannot compare them. We can say that complex numbers in general are not comparable, or the order relation is not defined. This symbol has no meaning in complex numbers in general, because real numbers are also complex numbers. In real numbers, it has a meaning because there is a linearity. All the numbers are arranged in a straight line. Here it is not the case. And there is an interesting joke about this. Two persons were talking on the Facebook. They were chatting, in fact. So one of them happened to be a boy, and the other one a girl. So the boy asked, "What is your age?" She said, "I can't tell." "Okay, tell me the group. In which age group do you fall?" She wrote, that means I am more than 16 years but less than 20 years. Here I don't believe, because he was a mathematics student. He said, "No, order relation is not defined in complex numbers." You are not correct. So this was meaningless for him. Anyhow, coming back to our problem. Because you are on Facebook, you are used to writing what you call that, acronyms. I mean, you don't write in full, just code your messages. A message would be written as MSGS, no vowels required. Anyhow, so let us come to this. Which one of the two numbers is farther from the origin? Now this question can be answered. Now what we have done is, we have taken two numbers and we want to know which number is farther from origin. If you are given a complex number Z, which will have a real part and an imaginary part, if this is the number, you know what is mod Z? The modulus of the complex number? It is x square plus y square under the root. And what is it representing? The distance from the origin. This is to be understood clearly. If this is O, this is P, because I know this point is representing x, y. So this OM will be x, OP will be y, and therefore OZ will be x square plus y square under root, or the modulus of that. So this you must keep in mind. The geometrical significance of modulus, it represents the distance of the complex number Z from origin. Is that okay? So now if you have to see which one of the two complex number is farther from the origin, that means the number whose modulus is bigger will be away from this. So 9 minus iota has modulus square root of 82. And what about 3 plus 8 iota? It is 9 plus 64. So we know that this is bigger. That means if we plot the two numbers, this number will be at a distance root 82 and this number at a root 73. By the way, what is the exact location of these points? 9 minus iota. Where is 9 minus iota? No. Where is the location of this point? It is 9 minus 1. How do you represent a complex number? A plus B iota in the complex plane is represented as AB. What I am saying, if there is a number A plus B iota, complex number, the point in the complex plane which represent it is AB. So what about 9 minus iota? It is going to be somewhere here in the fourth quadrant. And what about 3 plus 8 iota? Somewhere here in the first quadrant. So this point is farther from origin. How we know that? We calculated this distance. Always remember that location of a point, in which quadrant does it lie, does not affect its distance. I mean, a point in the first quadrant may be very near to origin than a point in the third or fourth or fifth quadrant. Here quadrant is not mattering. The only thing is how is the distance. So that means we will be calculating modulus and verifying. Is that okay? Let's go to the next slide. Oh, now which of the following two complex number is farther from x-axis? You know that when I write a complex number x plus iota y and try to represent it on the complex plane x plus iota y, this distance is x and this is y. So what we are looking for is distance from x-axis. So distance from x-axis is y coordinate. That means the imaginary part of the complex number represents its distance from the x-axis. So in the first two numbers, 2 plus 3 iota and 1 minus 5 iota, which one is farther? 1 minus 5 iota. So we have to see the modulus, I mean. Although it is lying somewhere here, 1 minus 5 iota means in this quadrant, and 2 plus 3 iota. So this distance is 3. Although this number is 1 minus 5 iota, but this 5 does not matter to us. This distance is 5. That means in order to find the distance of a complex number from x-axis, you will take the modulus of the imaginary part. Similarly, the next question can be solved now. This one. Now, if you are asked to find out distance from y-axis, again it is okay. You take the modulus of the x coordinate, that means the real part. That means this particular number 1 minus 5 iota is closer to y-axis than this particular number. So these are two numbers. If you compare their distances from y-axis and x-axis, while this number is closer, is farther from y-axis than this number, and this is farther from x-axis than this given number. Okay. There may be numbers in which, say, I compare 2 plus 3 iota and 5 plus 6 iota. In this case, distance of this number from y-axis or x-axis, whatever we take, is more than the corresponding distances of this number 2 plus 3 iota from x-axis and y-axis respectively. Then why only axis? We can try out distances from other points also, from other lines also. So in the next question, I have taken the line y is equal to x. And the question I have posed is, there are two complex numbers, 3 plus 4 iota, and the other is 4 plus 3 iota. Which is farther from this? Can you try this problem? Let us also see. One idea will be depending purely on coordinate geometry. You know that if there is a straight line, ax plus by plus c equal to 0, and there is a point, say x1, y1, how do you find distance of this point from this line? The formula is ax1 by1 plus c modulus square root of a square plus b square. So here the straight line given is y minus x equal to 0. The point is 3 plus 4 iota. 3 plus 4 iota means this complex number is represented by 3, 4. So let us find out the distance, substituting 4 for y and 3 for x, taking the modulus and dividing by the coefficients of y and coefficient of x. I get 1 by root 2. What about the next case? The other number is 4 plus 3 iota. This will be 3 minus 4 modulus divided by root 2. So 1 by root 2. So they are equidistant. So this is one direct method of finding out. So here you can see, while we are trying to solve a problem which seems to be a problem of complex numbers, but basically it's a coordinate geometry problem. And but can we see it some other way? Why even do this? Let us see it this way. Where is the line y is equal to x? So if I roughly plot 1, 2, 3, what will be this point? This will be 3, 3. If you have x is equal to 3, the corresponding point on the line y is equal to x is 3, 3. So your point will be somewhere here because it has to be 3 plus 4 iota. X coordinate is 3 and y coordinate is 4. What about the other point? 4 plus 3 iota? 4 and up to a distance of 3. When x is 4, when x is 3, this number was 3 plus 4 iota. Now when x is 4, this point is 4, 4. But our point is somewhere here. It is 4 plus 3 iota. So it seems that they are equal. This distance, and because when we are talking of distance of a point from a line, that means from the point you drop a perpendicular and see what is the length. But this is more involving, drawing the line and then exactly plotting the points and having a look. And if they are very close, you will get confused because these number and this distance and this distance with your eye you cannot compare sometimes. But one simple thing I am observing here is one point is 3, 4, the other point is 4, 3. What is the midpoint? What is the midpoint of 7 by 2, 7 by 2? And in this particular point, x and y coordinates are equal. That means it is lying on the line y is equal to x. So midpoint of 2 points is lying on the y is equal to x. That means both of them are equidistant. If I have a 1 point here and 1 point here, I am joining them. So midpoint is lying here. So what is happening is, in this case they are also, this line is perpendicular. I mean, this was one thing I could observe. Otherwise, you could have done it directly. Even the direct method was not difficult. I've just done this exercise because it will be useful somewhere else in other problems. You should have a clear idea what we are doing. The geometry should be very clear. Picture should be very clear. Okay, let's see more problems. Again, y is equal to minus x. Any idea about this? The line is y is equal to minus x. The points are 3 minus 3 iota and 1 plus iota. You can apply that formula, distance, but I am saying that just a little observation will immediately tell you what is the case. What is this point? What is the point corresponding to this? Is it lying on? It lies on the line. So its distance from the line is 0. Other point is not lying on the line because here x and y do not have opposite sign. How could you guess that this is on this line? Because x and y had opposite sign but equal in magnitude. So therefore it lied on this. But you can see that 1 plus iota, had it been 1 minus iota, both of them would have lied on this. But now one of them is lying on the line, the other is not lying on the line. So the point which is not lying on the line is definitely farther from this. Because distance of any point from any line will be positive or 0. If a point is on the line, distance is 0, otherwise it is positive. You don't have any concept of negative distances. Then what about this? Next question. Which of the following complex number is farther from the circle? X square plus y square is equal to 1. The 2 points are also given to you. How do you find the distance of a point from? Okay. how will you find the distance of a point from a circle? Suppose I have a circle and suppose I have a point here, 3, 5. The distance means if you there will be many lines that can be drawn through this, which are intersecting the circle, but you have one center of the circle. If you join these 2 points, you can see this will be normal, and this particular point where this line is touching the circle, if I draw a tangent here, this is perpendicular. When you join any point outside the circle with the center, this becomes a normal to the circle. That means it is in a perpendicular to the circle, and shortest distance is always the perpendicular distance, not only in case of a straight line but also in the case of a circle. But that perpendicular means it is a normal. That means let us find out the distance of the 2 points from the circle's center, and whichever will be greater will be farther, because every point outside the circle will be at least r distance away from the center. Let us see what is the circle here. X square plus y square equal to 1. So the circle is centered at 0, 0. And radius is 1. Now, what is this point? 3 minus 2 iota. That means we have to calculate its distance from the origin. That means its modulus. So Z1 here is 3 minus 2 iota. So modulus of Z1 will be square root of 13. Z2 here is 1 plus 4 iota. So modulus of Z2 will be root 17. So that means this point 1 plus 4 iota is farther from the circle because it's farther from its center. So this was basically a question of finding out the modulus, moduli of the 2 given numbers, but it was presented in a different form. But now it's clear. If you ever you are asked a problem like this, you never have to forget. So this is one more thing. If at all you come across a problem which you have never seen earlier, so just keep it in mind. If you have solved a problem say 10 times, similar problems, that will always remain in your mind. You know, you have the brain can store so many things, but if you are concentrating on one thing, it swaps it to your cache memory, the memory which is working together at the time when you are focusing on something. For example, if here we are studying complex numbers. Suppose I say what is an animal or what is an elephant, it immediately, the shape of an elephant immediately comes to your mind. So, but you are not always remembering what is an elephant, what is an elephant. So that's what, all the things are stored at the back of your mind, like in your computer's hard disk. But when you start working on a program, the relevant things come to your cache memory, what you call. So that is what that is what we require should happen. The moment you see a question, it should come to your cache memory and you can simplify it. Anyhow, let's go to the next problem. Now the questions are about argument. You know how to find argument. If x plus iota y is there, find out y, find out x, then tan inverse of y upon x, and then you have to take care of whether it lies in first, second, third or fourth quadrant. That's okay. But the geometry helps you here. What is this number? Where does minus 2 lie? Negative side of x-axis. Minus 2 is somewhere here. So if you join the line, which line? the line joining the point P which we are interested in and the origin, and you have to see what is the angle it is making with. Okay, because general definition is, if there is a point Z here, if we express it as R cos theta plus iota sin theta, then this angle is theta and this distance is R. So theta, or the argument, is the angle which your line OP joining O and the complex number Z makes with the positive direction of x-axis. And we normally count the angle this way. So it is -2. -2 is on x-axis, this side. What about -2 iota? -2 iota is somewhere here. So it is this. Okay. Then let's see the next problem. So what is the argument of a pure real number? That means which does not have imaginary part. It will be x plus 0 iota. That means it will be just a pure real number. It will either be positive or negative. If it is positive, it will lie here. A positive real number will lie here like 2. A negative real number will lie on the other side of the axis. So it is either 0 or pi. So the answer to question number 1 is either 0 or pi, depending on its real or this. Because if this is, had it been a objective type problem, what is the argument of a pure real number? The choice may be, say, 0 and pi, 0 and pi by 2, pi by 2 and pi. That means, what are the choices? Here the choices were 0 or pi. What about a purely imaginary number? Okay, either it will be pi by 2 or minus pi by 2, you can say, or pi by 2 or 3 pi by 2. Whether you traverse 3 pi by 2 rotating in the counterclockwise direction, or you traverse pi by 2 degrees moving in the anti-clockwise direction, both are same. So you will have to see the choices. What about 0? The argument of 0 is not defined. This is, you have to note. So before we move further, let us make certain things clear about the polar form. This is known as polar form of polar representation of a complex number. What is that? Whatever complex number is there, say Z, join the point representing Z to origin. There is R and there is theta. This theta is the. So sometimes instead of solving the problem, you can just, with the help of a drawing, by drawing a picture, you can guess what will be the argument of that particular number. We'll see some more problems on this. And because 0 is this point origin, you cannot, if you try to draw a line joining origin and origin, you will not get anything. It will just be a point. So now, this is something interesting. I don't know whether you have done a problem like this earlier or not. What happens to the following complex numbers if the lines joining to the origin, joining them to the origin, are rotated through 90 degrees in a counterclockwise direction? Let's see. Let's try to understand. I take this. Let us see this picture. Suppose your point is here. Suppose it is making, let me take a point like 1 plus iota. Now you know this angle is 45 degrees. This point is 1, 1. If I rotate this line through 90 degree, what will happen? It will come here. What will be this angle? 90. So what will be the total angle? So your number will be r cos 135 plus sine 135. And can you tell me what will be this r? Because you have rotated this point. If I rotate this pen in any direction, the length of the pen does not change. Original length, that means modulus, was square root of 2. So it will be this. So the new number is this. Can you calculate it? What is sine cos of 135? It is cos of 90 plus 45. It is cos 45 with a minus sign, because in the second quadrant cosine is negative. Similarly, sine of 90 plus 35 45, sorry, is what? Cos 45, and it is 1 by root 2. 1 by root 2. So the number is 1 by root 2, 1 plus iota. The number has changed. Is that okay? The real part was this, imaginary part was this, into root 2 was also there. So it is minus 1 plus iota. Now every time you can do this, but let's just see some simple method of doing it. Instead of doing all this calculation, the problem is the following. There is a point xy, because every complex number can be written as xy. If it is x plus y, its corresponding the point corresponding to this on the complex plane will be represented by xy. Suppose this is rotated, the line P and O is joined, and it is rotated through any angle theta degree. You get a new point. Let us represent it by x dash y dash, and the relationship is x dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta. If you just keep this result in mind, you can answer any question related to rotation. But before we use this formula, let us see these problems. I mean, this question where we were given a point, we joined it to origin and rotated the line through 90 degree. This had 4 parts. We have checked where will 1 plus iota go. Where will 1 go? 1 will go to, I'm not changing, asking you the argument only. Where will 1 go? On the y-axis. It will map to iota. Is that clear? See, this is 1, this is iota. So if I rotate this through 90 degree, because this distance will remain same, so 1 will be mapped onto iota. What happens to these points means where do they go, and where will iota go? Minus 1. Iota is here. If I rotate it, it will come to minus 1. Similarly, we can check up 1 minus iota, 1 plus iota. Because we are rotating through 90 degree here, our formula will be very simple. X dash is equal to, what is cos 90? 0. What is sin 90? 1. What will be y dash? Sin 90? and cos 90. So if I put theta is equal to 90 in these equations, I get this. So process is now simple. X dash is minus y and y dash is x. That means now I can immediately answer all the problems. 1 minus iota will be mapped to 1. X dash will become, just see what is x, 1, what is y, minus 1. So what will x dash become? 1. And what will y dash become? You can see where is the point 1 minus iota? This is the point 1 minus iota. If you rotate it through 90 degree, it will reach somewhere here. It will become 1 plus iota. So this formula is valid. So it is not only giving you finding rotation through 90 degrees, but through any angle, whatever you like. In theta, if I put here, equation gets simplified. If I put theta is equal to 180 degree, equation will be something different. What will be that? If I take theta as 180 degrees, x dash becomes x cos of 180, cos pi is minus 1. So minus x and sin 180 is 0. What about y dash? Sin 180 is 0 and cos 180 is. That means the point xy is mapped onto minus x minus y if you rotate the line joining the point and the origin through 180 degree in the counterclockwise direction. That means a point in the first quadrant is going to be mapped in the third quadrant. Is that true? Let us see this rotation through 180 degrees clearly. This is x-axis, y-axis, this is x-axis. Here is a point xy. Join with the origin, rotate it through 180 degree. The point comes here. Obviously, this is minus x minus y. There are a number of ways of proving it. You drop a perpendicular here, you drop a perpendicular here. You will see that these two angles are equal and these two triangles are congruent. So this is equal to this and this is equal to this. So x becomes minus x and y becomes minus y. But we are not getting into proofs. Just this set of equations always gives us the relevant matrix, relevant transformation. How to change x and how to change y. X dash x and y dash x and y are given by these equations. So I leave it to you for checking out for other rotations, 270 degree, 360 degree, it can be even 30 degree, 60 degree, or say 45 degrees. What happens if you rotate to 360 degrees? This comes back. So there will be no change. It's just like rotating your axis. A set of axes is there, you are rotating them. Or we are keeping them fixed and there is a point like this. We have joined it origin and we are rotating it. Counterclockwise direction or clockwise. If you do clockwise, if the question is it is rotated through clockwise by 30 degrees, in the clockwise direction through 30 degrees. So put minus 30 in this equation. Take theta is equal to minus 30 everywhere and you will get the result. So this is clear. And you will get used to these problems. There's something I have, again, something good for you. One mathematics student got a part-time employment in a telephone exchange, and see what happened. When he, see the next slide. When a call was received, normally the person answered that is a wrong number. But what he answered, you see, we are sorry, the number you have Dial is imaginary. Please rotate your phone through 90 degrees and try again. Because rotation through 90-degree make real things imaginary and imaginary things real. So that was an absurd application of the imaginary things. Mind it, imagine, even complex numbers are very real in the sense that complex analysis got a number of applications, particularly in electrical engineering and so on. But anyway, that was just for humor. Let us go to the next problem. So we don't have to learn this kind of mathematics. So now coming to principal argument. You know that when we talk of argument of any number, it is not unique. See this result, this third statement here. If theta is a value of the argument, then 2n pi plus theta also represent different values of argument where n can be any integer. Whether you take theta or 2 pi plus theta or 4 pi plus theta or minus 6 pi plus theta, all are the values of the same, are the arguments of the same complex number. So, because there are so many values, sometimes we want to restrict our values between this minus pi and pi. If we are given a complex number and we find out its value between minus pi and pi, this is called the principal argument of set. The argument of a complex number lying between minus pi and pi. So we have to find the principal argument of root 3 minus 1. That will be simple. I can leave this problem, but okay. Because we have not done even a single problem of this type. How do you do that? Oh, tan theta is equal to minus 1 upon root 3. Because this number is where root 3 minus iota is in the fourth quadrant. So what will the value? Pi by 6 with a negative sign. What? Either you call it 11 pi by 6 or, but since the question is find the principal argument, so you have to write minus pi by 6. Otherwise, two choices would have been correct. 11 pi by 6 takes it beyond that range, minus pi to capital pi, no, minus pi to plus pi. So this concept is clear. These questions you have done a number of times, so I just skip it. Let's go to the next problem. Okay. I don't think we have I've written the correct option here, but anyhow, the question, the important thing is how to solve this problem, because we are given x plus iota y raised to power 1 by 3 as a plus iota b. We have to find the value of x upon a plus y upon b. That means somehow looking at the answer, I mean looking at the expression whose value is to be evaluated, I should try to find the value of x and y. If I know the value of x, I can substitute here. So this equation can be rewritten as x plus iota y is a plus iota b cube. We can write the cube. It will be a cube plus iota cube b cube plus 3 iota cube is 1. No, it is not. 3a square into iota b plus a into 3 into iota square b square. Let me write the real and imaginary parts separately. Since this is iota square, it will be minus 1. So this becomes real part. A cube minus 3ab square. This is the real part. Out of the remaining 2, I take iota out. Iota cube is there. So what will happen? Iota square will be left out. So minus b cube plus 3a square b. So now I can see that if there are two complex numbers, they are equal, their real part should be equal and their imaginary part should also be equal. So x becomes this. Let me write it as a square minus 3b square. Y becomes this. Let me write, taking out b, it is minus b square plus 3a square. So this is helping me. X upon a is known to me now. It is a square minus 3b square. Y upon b is minus b square plus 3a square. So when you add them, you get something else. None of these choices. X upon a plus y upon b is adding this expression and this expression, you get 4 times a square minus 4 times b square. The last choice should have been none of these. I mean, even if there are 4, let me add another choice, 5th one, none of these. This is a typo, typing error. No? So this was a question where, knowing the concept, we could do the calculations. But how to calculate? I mean, you should not try to find the third root of this. We can find roots of complex numbers, third root, fifth root, but we are not going to try that. The simple thing is, let us write x plus y, because my aim is to obtain this x upon a plus y upon b. So I wanted to find out x, and I know that if I cube both sides, this will become x plus iota y and this will become a plus iota b cube. That can be simplified. It will have a real part, it will have an imaginary part. We can find the value of x and y by equating. Similarly, next question. But here, fifth power is involved. And you see, what is the question? A plus iota b raised to power 5 is alpha plus iota b, and I have to find the value of beta b plus iota a raised to power 5. Now, you can see answer is something like this. One of these, alpha plus iota b, beta plus alpha I. So that gives me an idea. I should not at least go for powers of this, because you won't be able to solve that equation. So the idea that immediately strikes is, you know this result? If I have z square bar and z bar square, they are equal. Whether you square the complex number first or take the conjugate later, or first you take the conjugate and square it up, it's equal. So let me use this result. A plus iota b raised to power 5 is given to me as alpha plus iota beta. Let me rub off everything. If I take the conjugate of both sides, it will become a minus iota b raised to power 5 is alpha minus iota. Now have a look at what you require. B plus iota a raised to power 5 is what we need. And see at the left hand side expression here. Can we convert it to this form? If I take minus iota out, this will become iota b, b, and this will become a iota, because minus iota multiplied with iota is that we do. First, let us see the expression. Iota into minus iota is 1. So writing a minus iota b as minus iota times a iota plus b is valid because there was power 5, we get this. But now what is iota raised to power 5 or minus iota raised to power 5? Iota raised to power 5 is iota raised to power 4 into iota, which is iota, because iota raised to power 4 is 1. If it is minus iota raised to power 5, we have minus iota raised to power 4 into minus iota, so it is going to be minus iota. So this expression becomes minus iota ai plus b raised to power 5 into alpha minus iota b. You can see that we have almost achieved what we wanted, b plus a iota raised to power 5. If I just in 2-3 steps I could obtain that expression. Now it's a matter of simplification. ai plus b raised to power 5 is alpha minus iota b raised to divided by minus iota. So we get beta minus 1 upon iota alpha. What is minus 1 upon iota? It's iota, because if you multiply both the numerator and denominator by iota square, sorry, iota, you will get iota square here. That will be minus 1. So it becomes plus. So it is beta plus alpha iota. Do we have a choice like this? D. So expanding this would not have taken us anywhere, because I always have a look at this. What I want to obtain, b, the value of b plus iota raised to power 5. So immediate thought was somehow trying to get this. And if I take this iota directly out, suppose I do not find the conjugate, I just take out iota, what will happen? This will become b and this will become minus iota. I can take the conjugate later, but we have to take conjugate in order to obtain this. Had the question been find the value of a minus iota b raised to power 5, a minus iota b raised to power 5, will just take conjugate of both sides. And similarly, you have a look at this and see what is to be done. So sometimes we thinking for a few seconds can help us. We need not go into very lengthy calculations. Let us proceed further and see some more problems. Oh, this I have kept because sometimes you may get questions where calculations you cannot avoid. Here what is given? X is a plus b, y is a omega plus b omega square, and z is b omega plus a omega square. Are they equal? No, they are different. Y and z are different. And you know what is omega? Normally it will be mentioned in the examination that omega is representing a non-real root of cube root of unity. You can see that how many square roots does one have? 2. How many cube roots? It has got 3 roots, 4 roots, 5. How many? These are square roots. What are 4 roots? 1 minus 1 iota minus iota. You know that? The idea is how to find x raised to power 1 by 4. I want it to be, sorry, I want to find a number x whose 4th power is 1. That is what we mean by 4th root. What we mean by a square root? Write a number x such that its square is equal to 1. We get equation x square minus 1 equal to 0, and we solve it, we get x is equal to 1, x is equal to minus 1. If this is the case, how many 4th roots? x4 minus 1 equal to 0. Solve, but for solving it, let us factorize it, and therefore what we get is x is equal to plus minus 1 from here, and x is equal to plus minus iota from here. So that is the technique of doing it. How do you find the cube roots? Cube roots are important. What is the number x whose cube is 1? That means solve x cube minus 1 equal to 0. X minus 1 into x square plus x plus 1 is 0. This gives you x is equal to 1. For solving x square plus x plus 1 equal to 0, you can see that by solving a quadratic equation minus 1 plus minus b square minus 4ac upon 2a, this is what you get, minus 1 plus minus root 3 iota by 2. This you have done perhaps. So the three roots of unity are x is equal to 1, x is equal to minus 1 plus root 3 by 2 iota, and the another is minus 1 minus root 3 by 2 iota. So we represent these roots by 1, omega and omega square. Omega is one of these value. Square of this you can see will be this. If you square it up, you will get this. You take this, you simplify and see for yourself. This you have done, so I am leaving. And what is the property of this? Omega cube is 1 always, because 1 cube is 1, and also omega square cube is 1. Why? The reason is that they are cube roots of unity. That itself says when you cube them, you get 1. 1 cube is 1, omega cube is 1, omega square cube is 1. And their sum is 0. This plus this plus this is 0. This is whole divided by 2. This 1 will cancel out with minus half and minus half, and root 3 by 2 with minus root 3 by 2. That is the imaginary part. So this is understood that even if it is not mentioned, the notation is so standard that 1 in this expression, omega you have to take as, and omega square both as the cube roots of unity, which are different from 1. So sometimes they write omega is a non-real root of unity, because real root is 1. It has got 3 roots, and if you have suppose 4th roots or say 6 roots, how many reals and how many non-real you have to find out. But mind it, complex roots always occur in pairs. If one root is 3 plus 4 iota, the other has to be 3 minus 4 iota. So this was a cubic equation, x cube equal to 1. It has degree 3. So there are 3 roots. 1 is real and 2 are complex. You cannot have 1 complex and 2 real. It will never happen. So you can have a question like this. A third degree equation with real coefficients has 1 complex root and 2 pure real numbers. Is the statement true? Answer is no. It cannot have. If 2 plus 5 iota is a solution, 2 minus 5 iota has to be a solution. This you should know. Anyhow, this question is a bit lengthy. You can see one or two things I see, and then rest I leave for you. You solve it at home. Is the first statement true? Let us see x plus y plus z. What is the value? A plus b plus a omega plus b omega square plus b omega plus a omega square. How many terms contain a? 3 terms. 1 omega plus omega square. B omega plus omega square. But 1 plus omega square is always 0. So it is 0. A and B, the coefficient of both of them is 0. So first statement is incorrect. Because you had b omega, you had b and you had b omega square. So when b is taken out, there were 6 terms. 1, 2, 3, 4, 5, 6. So I've written all the 6 terms. 3 terms had 1, other 3 terms were, so 3 terms had A as a factor and 3 terms had B as a factor. I've taken them out. Inside we are left with 1 plus omega square. But since that is 0, we always find that x plus y plus z is 0. Actually, so many questions can be found from this. This is not a good objective type question, but there's a lot to do because you have to say which one of them is true. Had it been which of them is not true, we could have tried first. If that is not true, we are through. If first is done, first is true, second is not true, we are done. But here we have to check all of them unless we know that 3 of them are not true. So finding out x square you will do. X square will be a square plus b square plus 2ab that way. Similarly, write down x square, write down a y square, write down z square. There will again be combinations of 1 omega square and you can simplify. And try to find x, y, z and this also. You will do it. But one thing you will need is whenever there are 3 numbers satisfying this, then we know x cube plus y cube plus z cube is how much? Something like 3xyz. That is the result now. So because you have to find out x plus y plus z for this, solving this, then x square plus y square plus z square, then also x cube plus y cube plus z cube. But what you can do is, since x plus y plus z is 0, we'll immediately jump to the 4th problem. We'll first find x, y, z. Whatever is the value of x, y, z, 3 times that will be x cube plus y cube plus z cube. That is the only consolation कि हमें कहीं पर तो थोड़ा काम करना पड़ रहा है, नहीं तो x का क्यूब करना, y का क्यूब करना और z का क्यूब करना और उसमें 2 एक्सप्रेशन है फिर उनको ऐड करना. But that we can be spared. So if at all this is the question, we'll solve this, then we'll solve this. If none of them is true, because we are assuming that only one answer will be correct. If the first part comes out to be true, we stop. If the second part comes out to be true, we stop. Okay. You are noting down something? Okay. If first 2 are not true, we immediately jump to x, y, z. That's how we can save some time. If you have tried all the problems which were simple and you could write directly, and you have time for concentrating on those problems where a lot of calculation is involved, then you can try this. But there also we apply some tactic and try to do it in minimum possible time. Okay. Sum of the roots of unity. This is not only by cube, only for cube roots or square roots. It has got 2 square roots, 1 and minus 1, sum is 0. 3, 1 plus omega, 1 omega and omega square, sum is 0. 4th roots, 1, minus 1, iota, minus iota, 0. Always 0. What about product? What is the product of minus 1? Yes. Sometimes it will be 1, sometimes it will be minus 1. So 3rd is the choice. How did you check? For 1 and minus 1, for square roots, 1 into minus 1 is minus 1. For the 4th roots, it is cube roots, 1 into omega square is omega cube, which is 1. For the 4th roots, 1 iota, minus iota and minus 1. The product comes out to be iota square, which is again minus 1. So actually, there is something you should know. Maybe you have not studied it in your 11th class, but since ultimately you are preparing for a competitive exam like IIT, and it is to be held a year later, so you can start storing your results and knowing things. We come to something like this: ax square plus bx plus c. This is your standard quadratic equation, but a should not be 0. That is the condition. Only then it will be quadratic. Otherwise, If a becomes 0, it will cease to be a quadratic equation. It will become a linear equation and will have only one root. Suppose its roots are alpha, beta. Then you have read that alpha plus beta is minus b upon a, and alpha into beta is, and this can be carried forward for third degree, fourth degree, fifth degree, all equations. So if you have an equation like this, ax cube plus bx square plus cx plus d, how many roots will it have? It will have three roots, alpha, beta, gamma. So if you want to find out alpha plus beta plus gamma, it will be minus b over a. If you want to find alpha into beta plus beta into gamma plus gamma into alpha, it will be c upon a. And if you want to find out alpha into beta into gamma, minus d by a. That means sum of the roots. This means sum of the products of the roots taken two at a time. If there are three roots, what I am doing, I am multiplying alpha into beta gamma, beta into gamma, and adding them. That is given by minus this plus this upon this. And finally, last one. So we write a minus sign for this, a plus sign for this here. I should write here minus sign with plus sign with minus sign. It does not mean that this will come out to be positive. If one of C or A is negative and the other is positive, it will come out to be negative. I am also only saying in this formula we do not put a minus sign. Okay, similarly it can be extended to fourth degree equations. But what will that mean? Sum of the roots taken two at a time, sum of the roots taken three at a time, and if I have four numbers, alpha, beta, gamma, delta, alpha plus beta plus gamma represents sigma alpha. In short, we write it is sum of roots. I write sigma alpha beta, which means sum of the roots taken two at a time. Now it's a problem on permutation. You are given four numbers, alpha, beta, gamma, delta. How many products like alpha, beta can you form? You have to select 2 out of 4. 4C2. You will get 6 things. 4C2 will be 6. Because you can get alpha, beta, alpha, gamma, alpha, delta, beta, delta, gamma, delta. Anything. You keep on. Can you see that? And what about sigma alpha, beta? So I can write alpha, beta, alpha, gamma, alpha, delta, then beta with gamma, then beta with delta, and then gamma with delta. 6 are there. And if you're writing a fourth degree equation, suppose this is the last one I'm taking, then I'll come to cube roots of that. Suppose it is ax4 plus bx cube plus cx square plus dx plus e. What will be sum of the roots? It will be minus b by a. If you want to find out sigma alpha beta, I'm not bothered about what will the expression. It will be c by a. Sigma alpha beta gamma, it will be minus d by a, and alpha beta gamma delta e by a. You can see I have not written summation here because there are 4 roots alpha, beta, gamma, delta. If you multiply all of them, there will be only one term. Here, sigma alpha, beta, gamma will have 4 terms because out of 4 things you are choosing 3 at a time. You can choose alpha, beta and gamma, alpha, beta and delta, and alpha, gamma and delta, and beta, gamma and delta. You can try it. You know from permutation combination, there will be 4 such terms. But this is sufficient. My question here was about the sum of the roots and product of the roots. When we are finding out, say, fifth roots of unity, what will you do? How will you solve it? X raised to power 5 minus 1 is equal to 0. So if you are asked to find out sum of the roots, how will you do? Coefficient of x4 divide by coefficient of x5. That's how you do. In a fifth degree equation, how will you find the sum of the roots? Coefficients of x4 with a negative sign divided by coefficient of x5. But here, fourth degree term, third degree term, second degree term, and x term is missing. So therefore, sum of the roots will be 0. Sum of the roots of products taken 2 at a time will be 0, 3 at a time, 4 at a time, everything will be 0 because you don't have the coefficients. And what will happen to this product of the roots? It will be 1. So if an odd degree is there, normally you will be having, you won't have to put a negative sign. You have to check up. You have to check up. If I write it as x5 plus 0x4 plus 0x cube plus 0x square plus 0x plus minus 1 is equal to 0. So for this, a negative sign divided by 1, a positive sign divided by this, negative sign, positive sign, negative sign. So you will have to take care of that. So that's why product of the roots will be either 1 or minus 1. If you are talking of a cubic second degree equation, you are solving x square minus 1 is equal to 0. And you can find out alpha, beta, gamma. So with the help of this problem, we have seen, in fact, not only finding out the sum of products of roots of unity, sum of the roots of unity or a product of roots of unity, we can find out sum of roots or product of roots for any given equation, provided it is a polynomial equation. We are talking only in terms of polynomial equations. If it contains sin x, cos x, the result is not true. So what more, one thing we have derived, for all the nth roots of unity, sum of roots taken 2 at a time or 3 at a time will come out to be 0 because the coefficients in between are lacking, they are missing. अगर आपको ये कहा गया कि 6x के सॉरी 1 के 6 रूट्स निकालिए, आपको क्या करना है? You have to find a number x such that x equal to 1. That means the equation to be solved is this. So whatever be the 6 roots, one thing is sure, their sum will be 0 and their product will be depending on this factor. And in between, taken 2 at a time, you take 3 at a time, multiply, add, it will become 0. This is something you should keep in mind. One can frame questions on this. Okay, we have spent quite a lot of time on this. Let's. Distances are very important. Actually, a lot of mathematics depends on the fact that we can find distances. If we cannot find distances, a lot of mathematics will not be possible to do. Will not be able to do a lot of mathematics. We can find distance between 2 points on a line. We can find distance between 2 points on a plane. We can also find distance between 2 points in space. If we take 2 points in this particular room, for example, one is on the floor and one on the say roof or the ceiling, we can join them and find the distance. The idea of 2 dimension can be extended to 3 dimension and to higher dimensions. So here we are asking very simple question. We are on a plane. What happens to the powers of I? Question is, I की कौन सी power I से सबसे ज्यादा दूर है? I cube is, okay, what is distance between I and 1? What is the distance between I and minus 1? By the way, the geometry tells us everything about this. Your answer is correct. Suppose I plot the powers of I. I is here, this is I. What is I square? Minus 1 I cube minus I4, 1. Distance between them is, and distance between I and minus 1 is, what is distance? Can you find out? What is this distance? 1. Again, what is the distance of I from x-axis? The coefficient of, modulus of the coefficient of its imaginary part. So it's root 2. This is also root 2. This is also root 2. This is also root 2. And this is 2. Distance from this point A to B is 2. So the farthest points are, I have asked which point is farthest from I. The farthest point from I is this point, because other points, powers of I are these are the 4 powers of I, and farthest are these. So if you take consecutive powers, I and I minus 1, they are root 2 apart. I square and I cube, they are root 2 apart. I cube and I4, they are root 2 apart. And if you take alternate powers, I and I cube, they are distant 2 apart. The distance between I square and I4. So these questions, these results now are there in your mind. The geometry makes it very clear. And any question formed on the basis of this can be answered. Because here, in this short span of time, maybe 2 hours or 2.5 hours, we cannot solve all the problems. So the best thing is you should have an in-depth understanding of various concepts. And in complex numbers, a lot can be done with the help of geometry. Okay, let us proceed. What is the value of 1 plus omega n plus omega 2n if omega is a cube root of unity different from 1? That means of the 3 cube roots of unity, we have excluded 1. So omega is a non-real root of unity. So it can be either omega or omega square, whatever we take. Omega is 1 root. So what is this sum? How to find? You can see what is the value. Suppose I take, this is one method of doing it. It's just by observation. Suppose I take n as 1. What will happen? 1 plus omega is 0. Suppose I take n as 2. 1 plus omega square, omega 4. What is omega 4? Omega 4 is omega. You should know about this. What is omega 4? It is omega cube into omega. So it's omega. So it's 1 plus omega square plus omega. By the way, what is omega? 25. Because we know that omega cube is 1. So it will be omega cube into 8 into omega. What is omega? 27. Omega cube. Omega cube is 1. So it is going to be 1. You can always find the power of any integral power of omega, positive integral. Similar for I. You know what is iota 71? Because you know what is iota raised to power 4. How many complete 4s are contained in 71? Iota raised to power 61, 68 is 1. So you will be left with iota cube. Iota cube, you know how to find out. So that's how we do. But can we reduce that? It is 0. Suppose I take n is equal to 3 now. What happens? 1 plus omega cube plus omega 6. What is omega cube equal to? What is omega 6 equal to? So you are getting 3. So far as this is concerned, it's done. You tried 1, 2, 3 and you saw that it is coming 0 or 3. Now the bigger question is, this is done because there is no other choice. 0 is correct, 3 is correct. We should not jump immediately from this because one case is not the proof. So I tried 2, 3 values. If somebody tries n is equal to 2 and checks 1 के लिए भी 0 आ रहा है, 2 के लिए भी 0, तो मैंने 3 और ट्राई कर लिया. Okay, I knew also it's not the case. But can you tell me for what powers of what values of n, positive integral values, this result will be 0 and for what values it will be 3? Suppose I take omega equal to n is equal to 4. If I take n is equal to 4, the result 1 plus omega 4 plus omega 8. What is omega 4? It is omega. Omega 8 is omega 6 plus omega into omega square. It is coming out to be 0. Yes, that is the correct choice. Whenever you get multiple of 3, whenever you take n as multiple of 3, omega cube will become 1. So if you are taking, for n, if you are taking 3 or 6 or 9 or 12, omega 9 will be omega cube of it. So it will become 1. Similarly, when n is 3, this becomes 6. When n is 9, this becomes 18. So whenever power of omega is an integral multiple of, positive integral multiple of 3, you will get the result as 3. So now a question you can form is, the value of this when n is equal to 3k, where k is an integer, is equal to 3. When it is not equal to 3, not a multiple of 3, any number, given any number, it can be written in 3 forms. This you should know. I mean, these are general things about numbers which will always help you in mathematics. Any number, suppose I take x, it's any positive integer. Let's concentrate only on positive integers. And I take 3. This can be written as 3n or 3n plus 1 or 3n plus 2. No other way. Because if you take 8, what is that? 3 into 3 into plus 2. Take 27, it is 3 into 9. Take 101. Okay. What is the reason? You divide any number by 3, what will the result? Remainder 0 or 1 or 2. So that means how we have obtained this result? We divide x by 3. You will get something as the quotient. Suppose n, so remainder will be 0 or 1 or 2. If it is 0, you get something of this type. If it is 1, we get something of this type. If we get 2, this is true now for any number. Suppose we talk with respect to 5. X can be written as 5n or 5n plus 1, 5n plus 2, 5n plus 3 or 5n plus 4. The result is generalized. When you are dividing any number by 5, the remainder can be 0, 1, 2, 3, 4 and so on. Okay, we go to next question. So from every question we are attempting, you can see that we are finding some more results about numbers, mathematics in general, and this develops our logical reasoning also. If you are good at these things, you will be able to solve a number of problems which you have not done earlier. Now, this question, omega is not equal to 1 is a cube root of unity. Again, because this is clear, whenever I say different from 1, that means I am either considering omega or omega square. Then the least positive integral value of m is. Read the question carefully and see if you can attempt. What we have to evaluate? 1 plus omega square, and this is given to us. These two expressions are equal. What is the least positive integral value of m for which this is true? One thing could be you could substitute 1, you can substitute 2, 3, 4 and try. But one thing is 1 plus omega square plus omega, this is always 0. So before doing anything, let me first of all write it as 1 plus omega. This is the first thing we should do, because any power omega more than 2 is useless for us. Omega cube is 1, omega 4 is omega, omega 5 is omega square. So let us first of all do it like this and then use this relation. What is omega plus 1 plus omega square? Minus omega. So it is minus omega raised to power m. And what is 1 plus omega? Minus omega square raised to power m. This means minus 1 raised to power m into, or let me divide directly. Let me write 1 is equal to minus omega square divided by minus omega raised to power m. Can I perform the division? When we cannot perform the division, suppose AB is C, I can write B is equal to C by A only when A is non-zero. This you know, if A is 0, you cannot write this. So whenever dividing, you must be very careful. The number you are dividing by which you are, should not be 0. But this number cannot be 0. We know what is omega, minus 1 plus root 3, that. So what is this? Omega raised to power m is 1. So minimum power of omega for which is 3 is this. If the calculation is okay, then it is 3. If you have committed some mistake, but the technique you know. What I did is I just got rid of this higher power. अगर 4 ना होकर 41 भी होता मैं इसको सॉल्व कर लेता, क्योंकि ओमेगा रेज टू पावर 41 क्या बनता, बिकॉज ओमेगा 39 विल बी 1, सो इट वुड हैव बीन ओमेगा स्क्वायर. फिर 1 प्लस ओमेगा स्क्वायर को हम माइनस कर, माइनस ओमेगा कर. So given any problem of this type, this is something you can try. This idea of converting the powers and then this. So let's go to the next problem. Okay. Somebody please tell me which of the following statements is correct for any complex number. When I say that the statement is true, that means for every z this should be true. You cannot try one z and if z is x plus iota y, what is real part of z? And modulus of z? So any one of these you think is correct? What does C mean? C means x plus y is equal to under root square x square plus y square. Is it true? It can be true for some numbers x0 y0, but it is not true in general. If I put x equal to 2 and y equal to 3, this is going to fail. So C is not correct. Pick up any complex number, say 2 plus 3 iota. What is mod z? It is square root 13. Is B true? Imaginary part is 3 less than root 13. This is not correct. Similarly, you can see the first is not correct. So none of these is the answer. We know that, but one thing we know. I know that mod z is always greater than or equal to real part. Why? This is x square plus y square under root. This is just x. That means under root x square. It is just x. So this is x square plus something positive, and then the square root is taken. Similarly, we have this result mod z. Had the last choice been mod z greater than equal to real z and mod z greater than equal to imaginary z, then it would have been correct. But none of the results that were there in the choices 1, 2, and 3, that means A, B, and C, are correct. Okay. Let's proceed. What about this question? If argument of a number is 0, what can happen to z? Z is 0, z is equal to z bar, z plus z bar is 0, z bar is 1. Let us see. When you say argument of a complex number is 0, that means we have done results on arguments. That means it's lying somewhere here on the positive side of x-axis. Z is 0. Z is equal to z bar. This gives what? The number is, if z is x plus iota y and z bar is this, what do you get? Iota y times 2 is 0. That means y is 0. So first choice is, what can you say now? Part C is correct. I think you have to think a lot. Z is actually, z is equal to 0 is not the case because argument of z is not defined. Let us rule out one by one. What about second? If z is equal to z bar, it is true. Actually, if somebody asks you what are all the possible numbers for which argument z is 0, then they can be real numbers on the, positive real numbers or negative real numbers. So second choice is satisfied. So assuming that only one choice is correct, so we just stop here. We need not go further. Z plus z bar is equal to 0 gives you something else. Because that will mean, what will that mean? X plus iota y and x minus iota y is 0. This means 2x is 0. That means you are talking of those numbers for which x is 0. They are imaginary numbers. And similarly, z bar is equal to 1. What is this representing? Mod of z is 1. What is mod z is equal to 1? What is the locus of these? If you collect all the points whose modulus is 1, what you get? It is a circle and center at. So this is the so far as solving this problem was concerned, you could have stopped at second choice, but we have seen all the options. What kind of numbers are represented for by these z which are satisfied? Okay, we proceed further. We have still so many questions to do. Is it true that mod z is equal to a always represents a circle? You saw that mod z is equal to 1 is a circle which has center at 0 and radius 1. If I take mod z equal to say 5, it will be a circle of radius 5 centered at 0, 0. So now my question is, let's see who answers this correctly. Is it true that mod z is equal to a always represents a circle where a is a real number? When it does not represent? When a is okay, then it becomes a point. Okay, let us that also include that also a circle with 0 radius. Let us assume a point can be always, because what's happening? Suppose this is circle with radius 5. I go on reducing this number. What will happen? Radius will. Okay, in the limiting case, if I assume a single point is a circle with radius 0, let us assume that. Your answer is correct. For 0, it's not representing a circle, it is representing a point. But I am saying, let us assume that a single point is also a circle with radius 0. Any other? Why not 1 by 2? Circle can have radius. That means you don't want negative numbers. That's correct, because this equation is not satisfied. That is what I wanted. For positive real numbers, or you can say non-negative if you want to include 0. Equal to 0 case is just a point circle. So the answer is no, it does not represent a circle when a is negative. Okay, let's go to the next problem. These are some good problems. Now suppose I take the first question. On this slide, the question is z minus 3 iota, z plus 3 iota, this modulus is equal to 1. What is the locus of z? Locus, you understand? Any point on the complex plane represented by z, if it is satisfying this equation, we collect all those points and join them, what will we get? There are two ways of doing it. I mean, you can find more ways. Suppose I take z equal to x plus iota y, substitute here, what it will become? X plus iota y minus 3 iota is equal to x plus iota y plus 3 iota, and try to simplify these equations, because this has a real part, this has an imaginary part also. Similarly, this portion has a real part and imaginary part. We can find the modulus on both sides. It will be the real part square plus imaginary part square, and then simplify, we'll get an equation in x and y. But I don't want you to do this. You do it at home. But for the time being, just observe that this equation is equivalent to z minus 3i is equal to z plus 3i. And now see, what is the interpretation of z? What does mod z represent? Distance of z from origin. And if I write z1 minus z2, this represents distance between z1 and z2. Okay. So what does this represent? distance between z and 3 iota. This represents distance between z and minus 3 iota. So this question now becomes which are the points which are equidistant from 3 iota and minus 3 iota? Just I reason it out again. This side is z minus 3 iota. The right hand side is z minus 3 iota. So this means we are trying to find those z whose distance from 3 iota and minus 3 iota is same. And where is 3 iota? It is on 3 iota is somewhere here, and minus 3 iota is somewhere here. So can you tell me now which are the points which are equidistant from this? Any point on x-axis. This point satisfies this result. If I take a point P here, this also satisfies this equation because this distance is equal to this distance. So every point on x-axis satisfies this condition. So that means we are trying to find out the perpendicular bisector of the line segment joining A and B, where A represents the complex number 3 iota and B represents the complex number minus. You can see how easily with the help of geometry you can solve. So therefore I insist that you do it taking z is equal to x plus iota y and see how much time will you spend collecting the real part of the left hand side and imaginary part. Similarly, collecting the real and imaginary parts of the right hand side, then writing x square plus y square for this, and then solving and simplifying. Do it at home. If you do it very quickly, say in 5 minutes, even then you have saved 5 minutes because it does not take much time. Just you have a look at the question and do it. Similarly, what happens to the next? Because now you are looking for those points which are equidistant from 3 and minus 3. The point 3 is here. The point minus 3 is here. What is the perpendicular bisector? This. Any point here on y-axis satisfies that this is equal to this. That is what was required in the second question on this slide. Z minus 3 is equal to z plus 3. That means which are the points which are equidistant from 3 as well as minus 3. So it's pretty simple. Let's go to the next slide and see some more questions. Now, I'm trying to make it a bit more tricky, but now you know how to solve them. Now the question is the locus of z minus 3 iota divided by z plus iota. This can be rewritten as z minus 3 iota is equal to z plus iota. That means which are the points which are equidistant from 3 iota and minus iota. This can be written as, let me write one more statement, z minus iota. So where is minus iota? Minus iota is somewhere here. Let me plot it here. Minus iota. Where is 3 iota? It is in the positive direction of x-axis. If I'm taking this distance as 1, it will be here. So what is the distance between 3 iota and iota? Distance between 3 iota and iota. It is 2, 4. 1 unit, 2 unit, 3 unit, and 1 step down, 4 units. So this will be the line. What is the line segment joining 3 iota and iota? It is AB. Let me darken it. Now it's perpendicular bisector. This will be a line parallel to x-axis. Y is equal to 1. Is there a choice like this? There is a choice, y is equal to 1. The choices could have been, it's a line parallel to y-axis. line parallel to x-axis. So such choices can be given. You may not be asked to find the exact equation, but just some property of the line. Similarly, the other choice can be equidistant from, when I say that z minus 5 upon z minus 1 is 1, it means z minus 5 is equal to z minus 1. So which are the points which are equidistant from 1 and 5? So we have to see where is 1 and where is 5. 1 and 5, in between we have 2, 3, 4. So which is the point? The midpoint of 1 and 5 is 3. So this particular line, that means x is equal to 3 is the choice. So now these problems can be solved. You can be given something like this. You try them. Suppose I write z minus 3 plus 2 iota upon z minus say 1 plus 5 iota. Problem is simple now. It has to be equidistant from 3 plus 2 iota and 1 plus 5 iota. So we join them, we get a line, the perpendicular bisector of that. We can also find its equation. You know how to find equation? You can find the midpoint of this. Then through that midpoint, the slope should be minus 1 times the slope of this. So problems can be complicated. Is that okay? So whenever 2 points are given, they may be lying in different quadrants. We can find their perpendicular bisector, because given 2 points, you know how to write the equation of the line. You know how to find the midpoint when 2 points are given, and passing through midpoint and perpendicular to the given line segment is the perpendicular bisector. So every time you will be able to solve this problem. And why only 1? We can have something else also. 2. That means if had the question been z minus 1 upon z minus 9 or say 10 is equal to say 1 by 3, suppose. That means distance of z from 1 is 1 by 3 times distance of z from 10. So what I will do, I will plot point 1, plot the point 10. What is 1/3 of? How many points are there? 2, 3, 4, 5, 6, 7, 8, 9. So this will be the 1 to 10. You find out whatever is 1/3 of this. 10 to 1, you have 9 points. So third point somewhere here. So this is the line. 1, 2, 3, 4. Now distance, this is 3. This distance is 6, because this is x equal to 4. So it's not necessary that we should have equal to. We can divide it in any ratio. Given 2 points, you know how to obtain a point which divides the line segment in the ratio m is to n. Even if I give 2 by 3, that you can solve. So I think this class of problem is well tackled. You will be able to. Let us see the next question. Oh, this requires a little bit of manipulation, but it is the same category of problem. Because here it is 1 minus iota z divided by z minus iota equal to 1. We have to find the locus of those points which satisfy this equation. So it becomes 1 minus iota z equal to z minus iota. Just take out I. take I from this. Let us take minus I z plus iota modulus z minus iota. You can break it. It is modulus of minus iota into modulus of z plus iota is equal to z minus iota. So what is the modulus of minus iota? No. What is the distance of minus iota from origin? Understand the difference between the modulus when you are talking of. Okay. So this question is simple. That means now it becomes find the locus of a point which is equidistant from I n minus I. That means again x-axis. So you just had to look at this and observe that we can express, we can reduce it to the problem which we have already solved. Okay, we go to the next problem. Now can somebody try this? In the equality I have changed to inequality. This would be a bit tricky, but take it from me, no calculations are required. I can take z is equal to x plus iota y and try solving, but that would be huge. That means I could have framed this question like this. What is the locus of points satisfying this? That means this is what is given in the question. Z minus 1 is, if I can read this, I have solved it. This means which are the complex numbers whose distance from 1 is greater than their distance from 3. So let us try to see with the help of geometry. Here is your y-axis. Here is 1. Here is 3. Which are the points whose distance from 1 is more than distance from 3? First, we shall have a look at which are the points for which distance is equal. All these where x is 2. Now any point here satisfies this. This is equal to this. Now which point, for which points distance from 1 will be more? On the left of it or the right of it? If I take a point here, you will have to travel more distance while going to 1 than going to 3. So this is interesting. You don't have to do anything. No calculations required. This is the insight required. So complex numbers on the plane you can see. If you can see the pictures, the whole mathematics is actually like this. But sometimes we get involved into large expression, like if you have to write x plus y raised to power 10, that visualization will not be here. But at least this facility we have for complex numbers. We can see with the help of pictures, and wherever a picture is there, we understand it well. So geometry of complex number therefore becomes very important so far as problems asked in competitive examinations is concerned. So had it been less than z minus 1, less than z minus 3, this part of this. Okay. The choices were a triangular region, a circular disc, a strip parallel to x-axis, a strip parallel to y-axis. In fact, parallel to y-axis. In fact, it should be the half plane. You know what is a half plane? Every line divides plane into two parts. In fact, two half planes. Suppose this is a straight line. If I take this as a straight line L, there are two planes. It divides into two. इसको ऐसा नहीं समझे कि ये टू दोनों का साइज सेम नहीं है, क्योंकि साइज की बात हम इसलिए नहीं कर सकते, प्लेन इनफाइनाइट है हमारा. It's not this mobile that we are dividing from here or here. It is infinite plane. So any line, if I take this plane and I draw any line, it divides into two half planes. So this is representing the half plane on the right of y is equal to, oh, sorry, x is equal to 2. X is equal to 2 was the case. I mean, even if this question is given, the choices can be different. Strip I would call something like this. Suppose if the result comes out to be x from 2 to x from 3. This will be called a strip. But anyhow, out of these, C is the most close answer. It should be the half plane on the right. Let us see the next question. How many complex numbers? Which are the complex numbers for which modulus is less than 3 but not greater than 2? Oh, sorry, it's greater than 2 but not more than 3. So lying between 2 and 3, 2 and 3 are included. Which are the complex numbers? Parallel? Sure. What is this? If I say mod z is equal to 2, which are these complex numbers? The complex numbers for which modulus is equal to 2, it can be this number, 2, it can be 2 iota, it can be this, it can be this, it can be any circle, any point on the circle having radius 2. You can see that this is circle with center at 0 and radius 2. And what is the representation of mod z equal to 3? It is a circle centered at origin and having radius 3. And we want that 2 should be less than or equal to z and less than or equal to 3. So it is this region which I am filling up with dots. It is a circular strip, a ring, you can say, a ring on a plane. Equal to 2 is also included. That means these points are included, all. Equal to 3 is also included. So you should also remember now that if z, suppose a is a real number which is greater than 0, mod z is equal to a represents a circle with center at 0, 0 and radius a. So if I talk of mod z less than a, it will mean all points within this. So if I rub off the circumference, the boundary, this represents mod z less than a, because I am not permitting z to have mod z equal to a. That means circumference points are excluded. If I write less than equal to, and if I write mod z greater than a, that means we have just taken out a circle out of the plane. If you draw a circle on a paper and just cut that, so this outside, let me write equal to, because okay, greater than a, that means you don't want to include anything which is inside. What you want is, if you don't include equality, these points are to be excluded. If you write mod z greater than equal to a, then circumference is to be taken. But this kind of thing you cannot draw that में. पेपर पे आप नहीं बना सकते जिसकी बाउंड्री ना बनाए, because जहां से भी आप काटेंगे बाउंड्री रह जाएगी. Okay, anyhow, that was just, so you understand the concept, like, and complex numbers are beautiful. I mean, when you go to engineering, you will see that a lot of complex analysis is being used in a number of things you cannot imagine. Electricity is flowing all over wherever you go, and electric engineers use a lot of complex analysis. Let's go to the next thing. Okay. If A is a real number, what is Z is equal to A iota? Are they representing? Now this is not mod Z equal to A, mind it. Here Z is a complex. Z is equal to A means Z is a real number. Z is equal to iota A means it's a pure imaginary number. Suppose I take Z is A is equal to 2 to understand. So what are the two things I am going to draw? Objects, shapes. Z is equal to 2. 2 means this. So it's a line. Z is equal to 2 means actually x is equal to 2. Z is x plus iota y. Z is x plus iota y. This means y is 0 and x is 2. And what is the equation of x equal to 2? Something like this. What is this? Z is equal to 2 iota. If I write it as x plus iota y, this means x is 0 and y is 2. So one such point is 2. But when I am letting it to be any real number, if instead of 2 I am permitting 2, 3, 4, everything, I will get the whole straight line. Had it been y is equal to a and a can be anything, root 2, root 5, everything is permitted, you get a straight line. So they are perpendicular lines. Because z is equal to a means x is equal to a. And a is any real number, that means straight line parallel to y axis. And this is parallel to this. So it was just to give you more vision. Questions can this be also there, and you can see the choice perpendicular lines in the plane. The idea is clear, I suppose. Please let's see the next question. Again this a iota and b iota, that means both of them will be parallel to x axis, so they are parallel lines. Because if this is z is equal to a iota and this is z is equal to b iota, suppose a and b are different, b is greater, so it will be above the line. Depends on a और b में से कौन सा बड़ा है, कौन सा पॉजिटिव है, कौन सा नेगेटिव है, उसके हिसाब से लाइन की लोकेशन होगी, कहां पर ये actually located होगी. But we are very sure that they are going to be parallel. If a and b become equal, they are coincident lines. तो equal to a iota रखने का मतलब लाइन हमारी horizontal है, equal to a रखने का मतलब हमारी लाइन vertical है. तो जब दोनों मैंने horizontal ली तो लाइंस पैरेलल आ रही हैं, दोनों वर्टिकल लेंगे तो भी पैरेलल आ रही हैं. Okay, this is simple. A concentric circles, you understand? Circles having the same center, like we just had a circle with radius 2 and a circle with radius 3, they were concentric, and we were trying to find out the area between them. Now the reverse questions can be there. You can be given an area and tell us what is the locus, what is the equation, which types of z can represent it. For example, if I draw something like this you can always say. Suppose this. All points lying in the first quadrant. What is the property of every point which belongs to every point in this? One thing can be x is positive, y is also positive. But in terms of complex number, you cannot say z is positive, because for z we do not have any concept like z is x plus iota y. We have no concept like z being positive or negative, because order relation is not there. Can we talk about arguments lying between 0 and pi by 2? So if I write argument z lies between 0 and pi by 2, okay, pi by 2 and 0 included. That means x-axis and y-axis are included. If I take strict inequalities, that means without these signs, that means it will be, they will not be excluded. Then the graph should have been drawn like this. So given a picture, we can see if this picture is drawn, that should be simple, something like this. Or suppose this picture is drawn 2 plus 3 iota. Oh, let me write a bit bigger. We leave this topic after this. We go to the next question. Suppose here is this picture is given 2 plus 3 iota and a circle is drawn, and this is 5 and a circle is drawn. This is 7 from this to this, and this is shaded region. So you can clearly see you want a circle centered at 2 plus 3 iota and area between the two concentric circles whose radii are 5 and 7. How will you represent it? Z minus 2 plus 3 iota. That's how you will represent a circle with center 2 plus 3 iota. It should be less than 7 and more than 5. This is the representation. Equal to 7 would have been the outer circle. Equal to 5, the inner circle. So between 5 and 7 means this circular, if this is a park, suppose you have flowers inside, this is the path on which you can move. Is that clear? So these graphical representations can be given, and you may have to look for the region. What is the region represented by the shaded portion? Okay, we proceed further. I want to cover a few more. थोड़ा ऊपर करें देखेंगे. Oh, it's 27. We still have say 18 slides. Let us see how many we can complete. If A and B are real numbers such that mod Z is equal to mod A and mod Z is equal to mod B, what they will represent? This question uses a number of questions we have just done. I have taken mod A to just avoid a situation where mod Z is equal to A may not represent any complex number. If A becomes negative, mod Z is equal to A may not represent any complex number. But mod Z equal to a positive quantity always represents a circle. So it and centered at 0, radius is mod A. So mod Z is equal to A is a circle whose center is 0. Mod Z is equal to B is also a circle whose center is 0. So they are concentric circles. Depending on mod A and mod B, their comparative values, which is bigger or which is smaller, which circle lies in and which lies outside, that can be decided. The question could have been framed, mod Z is equal to A lies inside mod Z is equal to B, and choices if mod A is less than B, mod B is greater than A, such choices can be there. mod A और mod B में से जो छोटा होगा वो circle अंदर आएगा, दूसरा बाहर आएगा. So this is just that question was important. Therefore, mod Z is equal to A, whether it represents something or not. It does not represent any complex number. If for real, for negative numbers, it does not represent anything. For 0, it represented a point. Okay. Next, let us go to the next problem. Okay. Now, which are the points on the circle which are the farthest from origin and nearest to origin? First of all, let us see what is this. Z minus 1 minus iota is equal to 1. This is a circle. What is the center of this circle? 1 plus iota. And what is radius? Can I draw this? The question will be done as soon as I draw it. I mean, at least it will be clear what is to be done. There is a point 1 plus iota. Where is that? 1, 1. This is the point 1 plus iota. The radius is 1. So how will the circle be? From here, if I draw, because this distance is 1 and this distance is also 1, if I draw a circle centered at this having radius 1, it will be something like this. Now a number of questions. The question could have been, is x-axis a tangent to this circle? Answer is yes, it is touching it here. Is y-axis a tangent? Yes. And what are the points of tangency? You can find this point is 1, 0, this point is 0, 1, or in terms of complex number, this is complex number 1, this is complex number iota. But now the question is, from origin, which point on the circle is nearest and which is farthest? Suppose I have this point, and let us first of all see it in general. This is a circle. On this circle, which point is nearest from this point? How to find? Suppose I draw a number of lines. The one which passes through center gives us the nearest point and the farthest point. Okay? You can see that if you walk from here and you have to move to this point, this distance is definitely more than. If I draw a circle here with this arc, you are traveling lesser distance. If I draw an arc with compass at here, this point, you reach here. So that means this distance is certainly. Now here our points are, this is our origin, this is the center. If I join them, what is the line I get? Y is equal to x. So intentionally the question has been set like this, that you don't have to do calculations in at least finding the line, because this point is 1, 1, this point is 0, 0, you join them, you get the line y is equal to x. Now the question is, at what points does the line y is equal to x intersect the given circle? It's as simple as this. Can you write the equation of this circle? Not in this form, in terms of x and y. It is x minus 1 square plus is equal to 1. This is the equation. We have converted the problem on complex number to a problem on coordinate geometry. And I want to find the intersection of this circle and the line y is equal to x. So let me put y is equal to x. So it becomes x minus 1 whole square plus x minus 1 whole square is equal to 1. That means 2 times x minus 1 square is 1. So x minus 1 is 1 by root 2. It can be plus, it can be minus. So I'm getting 2 points. X is equal to 1 plus 1 by root 2 and y, sorry. There are 2 values of x. If I solve y is equal to x and the equation of the given circle, there are 2 possible values of x. So we can find the corresponding values of y. Why? Because the point has to lie on the line y is equal to x. So the point will be either 1 plus this or any point on the line has x and y coordinates as equal. And our line x is equal to y. This is meeting our circle when x is this or x is this. When x is this, y has to be this. When x is this, y has to be equal to this. So the 2 points are, let me call A and B. So this point and this point, one of them is A and the other is B. So are there choices? Because this number, how will you write? 1 plus 1 by root 2 plus 1 plus 1 by root 2 iota. This number will be 1 minus 1 by root 2 and 1 minus 1 by root 2 iota. So do you have a choice like this? I think this is the correct answer, A. So not a difficult question. If if it strikes you, have to proceed. Drawing the circle, we observe that the center is 1 1. वैसे इसके लिए ड्रॉ करने की भी जरूरत नहीं थी, हमें वैसे ही पता चल रहा है. That drawing the picture gives you some insight कि what is to be done. This is the line y is equal to x. I took y is equal to x and the circle, and I solved the two equations putting y is equal to x, and I got this point. By the way, A is this, B is this. Which point is represented by A and which by B? Can you see that this is B and this is A? Why? Because this distance is 1 by 2. So 1 minus root 2 will be less than 1. This is 1 plus 1 by root 2. It will be greater than 1. So this point will be. Such problems can be asked in the examination. I think it has been asked a number of times in various examinations. Maybe in IIT also once. Let's go to the next problem. Yes, why not? Okay, somebody online wants me to repeat this problem which I had taken, that how to find out which point is farther from a circle. A circle is given to us. This circle was given to be x square plus y square equal to 1. First I ask a question. If this is a point, this is a circle with center C, and I am given 2 points P and Q, which point will be farther? How will you decide? Distance from the circle means when you join center with the point. Suppose I take P here. If I find out CP and I find out CQ, it will give us which point is farther from the circle. Because what is happening is, at least this portion, suppose this is A, this is B. CA is always equal to CB, wherever we take our points. Now the question is whether this is bigger or this is bigger. It is very clear in the picture that Q is farther than P. But it will be very difficult for us to find the point A or B. We'll have to find equation and everything. So what we do is we calculate the distance of P from the center, distance of Q from the center. If P, Q, or PC is less than P, QC, we'll say that P is nearer to Q than C. What is cube of unit? Cube of unit is 1. 1 raised to power. Unity, you understand, is 1. 1 cube, 1 fourth power. But if you are asking cube root of unity, that means what is the value of 1 raised to power 1 by 3? Suppose it is x. Then it means x cube is equal to 1. We have to solve this equation. So it has got 3 roots, as I have done already. You can write this equation as x cube minus 1 is equal to 0. It can be factorized as x minus 1 into x square plus x plus 1 equal to 0. First factor gives x equal to 1, and other gives you 2 roots omega and omega square. Mod of z minus 1 is greater than z minus 3. Okay. This question, let us see. If this is the point 1, this is the point 3, I am first asking which are the points for which z minus 1 modulus is equal to z minus 3. So this point 2 satisfies this property. Distance of 2 from 1 and distance of 2 from 3 are equal. This portion is equal to this portion. If I take any point on this distance will be equal to this distance. You can see, because this is the perpendicular bisector of 1 and 3. Now if I take any point on the right side of this line, which is x is equal to 2, you can see that this distance will be more and this distance will be less. If you take any point here, this distance will be greater than this distance. So we were interested in finding out those points for which z minus 1, that means distance between z and 1 should be greater than the distance between z and 3. Argument of z is not defined because if we take a point here, we have to join the line and find this angle. If the point is anywhere in the plane, near to origin or far away, wherever it is, we see that how to reach that point by rotating x-axis. A line segment on x-axis we take and we rotate. So what is the angle traversed? So this is the angle. But for 0, you cannot draw any line. So we have not defined in mathematics any argument for 0. It's not defined. Question on slide number 23 and 28. I have to see the question. What is that? Please go to slide. This is 28. Oh, I just repeat the concept. You please try yourself. What I have told is that this equation z minus 1 minus iota is equal to 1 this is representing a circle which has center at 1 1 and has radius 1. So this circle will be something like this, because it has radius 1 and this is 1 and this is 1, it will be repeated. Now we want to find which is the farthest from origin. If we start from origin and join the point with the center of the circle and continue with this line, it is intersecting the circle in 2 points. One will be the nearest to origin, one will be the farthest. So just find out the value where y is equal to x intersects x minus 1 square plus y minus 1 square is equal to 1. How do we obtain this? This is a circle which is having center 1 1 and radius 1. Let us also see the question on slide number 23. 23, yes. Oh, this is I've already done. Just I've told you. So let us see where were we actually on slide number 29. Oh, this is pretty simple. If you can observe that you are given the value of x plus iota y as 1 plus iota, 1 plus 2 iota, 1 plus n iota. You are supposed to find the value of 2 into 5 into 10 into 1 plus n whole square. You can see that if I multiply 1 plus iota with 1 minus iota, I get 2. If I multiply 1 plus 2 iota with 1 minus 2 iota, I get 5. So what we have to do is x plus iota y is given. Let us find out x plus iota y conjugate. That means x minus y iota. How do you find the conjugate of x plus y iota? Change plus to minus. This will be equal to conjugate of this whole complex number. So separately we can write 1 minus iota, 1 minus 2 iota, 1 minus n iota. Then if I multiply all the sides, both the sides, on the left and right hand side we'll get 2, 5, 10 and last 1 plus n square, because the last factors will be 1 plus n iota multiplied by 1 minus n iota. So we'll get this. So right hand side will be this and left hand side will be x plus iota y multiplied by x minus iota y. So we get y square x square plus y square. Have you understood? Do I need to write? Take the not understood? What you have to do is you take conjugate of both sides and multiply. I can do it. X plus iota y is 1 plus iota multiplied by 1 plus 2 iota, so on 1 plus n iota. X minus iota y will be 1 minus iota, 1 minus 2 iota, so on 1 minus n iota. Because x plus iota y is this, taking conjugate of both sides here, I get this expression. Now if I multiply on the left hand side, I get x square plus y square. And on the right hand side, this into this gives me 2. This into this gives me 5. And so on. This. Is that okay? Is that enough for the day? Or shall let us see what else is there? Oh, we won't be able to cover this. Actually, let's go. Do we have some time or no? Okay, then go to say slide number 33. Okay, I thought it would be a short break, but it is going to a final break. So let us see some more so the lighter side of complex numbers. See this a few things. And see the next slide. It's BTech was earlier called BE, and people used to find it very difficult. So it is very complex, they said. So somebody advised that it should be named as B plus iota E because it is very complex to pass it out. And let us see the next one. This is interesting. If PJ stands for a poor joke, what is a complex poor joke? It is P plus iota J. Somebody told. And finally, this one. This was interesting. Somebody, a mathematics student, went to a phone shop and said, "I want," instead of saying iPhone, I need iPhone 5. He wrote on the paper, "Give me this." Square root of minus 24 whole square. So don't get into these habits. But while you are working, I included these things. When you are working and sitting for long hours, just try to find these things also. So just say, if you are studying coordinate geometry, just Google jokes on coordinate geometry. You will find something. I just Googled jokes on complex numbers and I got some very interesting ones. So anyhow, good luck and revise your complex numbers well. And that's all for the day. Thanks.